Hey everyone, this is a Microsoft certified Azure Security Engineer Associate Certification course. In this course, you will learn about the roles and responsibilities of an Azure Security Engineer, which include managing the security posture of your cloud and hybrid environments. This course includes all the study areas you need to learn for passing the AZ-500 certifications, which include managing identity and access, implementing platform protection, managing security operations, and securing data and applications. I will make sure to put the timestamps on all the topics right below the like button so you can easily navigate between these topics. This course offers the combination of the right amount of lecture content and the demonstration and walkthrough related to that particular technology. I hope you enjoy learning this course and I wish you all the very best for your examination and continued career success. I have divided this course into four modules. The first module, it's all about managed identity and access. In this module, I will take you through different topics like Azure Active Directory, Azure Identity Protection, Enterprise Governance, Azure AD Privileged Management, Hybrid Identity, etc. The second module is where I will take you through what is perimeter security and network security, how can you implement host security, and how can you protect your container performing container security. Third module is where you're going to learn about Key Vault, app security, storage security, and database security. And on the fourth module is where you will learn about Azure Monitor, Azure Security Center, and Sentinel. And towards the end of each module, there is a knowledge check video as well. In the knowledge check video, we will go through few questions which will help us review the topics what we have learned, and it will help us do a quick knowledge check on what we have learned so far. Let's understand some exam basics. I'm sure if you're studying for AZ-500, you would have attended a Microsoft exam previously. So when you sit for a Microsoft exam, you can expect questions between 40 to 60. And not all questions were the same points. There are variations in terms of how the points are allocated. But one recommendation I would give is answer all the questions because there is no penalty for guessing. Total examination time would be around 180 minutes. So you can plan for 150 minutes for answering all the questions, and rest of the 30 minutes you can use it for reviewing, commenting, instruction, things like that. Definitely expect more than multiple choice questions. So what do I mean by that? So just don't go to the exam expecting that you're going to just pick few answers from the multiple choice questions. Expect hot areas or active screen or drag and drop, match the following, build this, etc. And definitely there are going to be case studies. At least there are going to be a couple of case studies on AZ-500 exam. And you most likely can get a lab scenario as well. Alright, so that concludes episode 1. In the next video, we are entering episode 2. That's where we're going to learn all about Azure Active Directory and how you can use Azure Active Directory to secure your Azure environment. Let's have a high-level look at what are the things we are going to learn on this video. We will start with all Azure AD features. Then we will dive deep into Azure AD versus Azure AD domain services. What are the different roles available in Azure AD? Then we will learn about Azure AD users, groups, etc. And finally, we will move into what is multi-factor authentication, what are its concepts, and how can you enable multi-factor authentication, and how can you implement the right settings for MFA as well. So without wasting any more time, let's get into it. Azure Active Directory, or it is known as Azure AD, is Microsoft multi-tenant cloud-based directory and identity management service. For IT admins, Azure AD provides an affordable, easy-to-use solution to give employees and business partners single sign-on access to thousands of cloud SaaS applications like Office 365, Salesforce, Dropbox, and Concur. For application developers, Azure AD lets you focus on building your application by making it fast and simple to integrate with a world-class identity management solution used by millions of organizations around the world. I'm on my Azure portal. You can search for Azure AD under global search box, and this is what Azure AD looks like. Azure AD also includes a full suite of identity management capabilities, including multi-factor authentication, device registration, self-service password management, self-service group management, privileged account management, role-based access control, application usage monitoring, rich auditing, and security monitoring and alerting. These capabilities help secure cloud-based applications, streamline IT processes, and cut costs. And this help you meet your corporate compliance goals as well. Before we dive deep into Azure Active Directory features, I want you to learn about what are the different Azure AD editions are available. Azure AD comes with 4 editions: free, Office 365 apps, Premium P1, and Premium P2. The free edition is included with an Azure subscription, and the premium editions are available through a Microsoft Enterprise Agreement, the Open Volume Licensing Program, and the Cloud Solution Providers Program as well. And the Azure and Office 365 subscribers can also buy Azure AD Premium P1 and P2 online. Let me help you understand what are these 4 editions on a high level. Let's first look into Azure AD Free Edition. The Free Edition provides user and group management, on-premises directory synchronization, basic reports, and single sign-on across your Azure, Office 365, and many other popular SaaS applications. So what is Azure Active Directory Office 365 apps? This edition is included with Office 365. In addition to the free features, this edition provides identity and access management for Office 365 apps, including branding, multi-factor authentication, group access management, and self-service password reset for cloud users. Now let's talk about Premium 1. In addition to the free features, P1 also let your hybrid users access both on-premises and cloud resources. It also supports advanced administration such as dynamic group, self-service group management, Microsoft Identity Manager, which is an on-premises identity and access management suite, and cloud write-back capabilities, which allow self-service password reset for your on-premises users. And the 4th edition is Premium P2 or Azure Active Directory P2. So in addition to the free and P1 features, P2 also offers Azure Active Directory Identity Protection to help provide risk-based conditional access for your apps and critical company data, and privileged identity management to help discover, restrict, and monitor administrators and their access to resources, and to provide just-in-time access when needed. So this Azure Active Directory pricing page has all the detailed information on what is included in each of these editions. Based on the feature list, you can understand which edition is best for your requirement. Please note that if you are an Office 365, Azure, or Dynamics CRM online customer, you might not realize that you are already using Azure AD. Every Office 365, Azure, and Dynamics CRM tenant is already on Azure tenant. So now that we have learned about what are the main features and the editions available in Azure AD, so now let's go and explore how Azure AD is different from ADDS or Active Directory Domain Services. Although Azure AD has many similarities to ADDS, there are also many differences as well. It is important to realize that using Azure AD is different from deploying an Active Directory domain controller on an Azure virtual machine. So let me take you through some of the key characteristics of Azure AD that makes it different. Azure AD is primarily an identity solution, and it is designed for internet-based application by using HTTP and HTTPS communications. Because Azure AD is HTTP and HTTPS based, it cannot be queried through LDAP. Instead, Azure AD uses REST API over HTTP and HTTPS. And because Azure AD is HTTP and HTTPS based, it does not use Kerberos authentication as well. Instead, it uses HTTP and HTTPS protocols such as SAML, WS Federation, and OpenID Connect for authentication, and OAuth for any sort of authorization as well. So what are the authentication services available in Azure AD? It includes SAML, WS Federation, and OpenID. And what are the authorization services available in Azure AD? Azure AD Users, or auth. So what about federation services? Azure AD includes federation services and many third-party services such as Facebook, LinkedIn, etc. And Azure AD gives you a flat structure. Azure AD users and groups are created in a flat structure, and there are no organizational units or group policy objects. And please note that Azure AD is a managed service. You only manage the users, groups, and policies. Deploying ADDS with virtual machine using Azure, meaning that you manage the deployment, configuration, virtual machines patching, and other backend tasks as well. Let's understand some of the Azure Active Directory administrative roles. Using Azure Active Directory, you can designate limited administrators to manage identity tasks in less privileged roles. Administrators can be assigned for roles such as changing users, assigning administrative roles, resetting user passwords, managing user licenses, and managing domain names as well. The first thing we need to learn about is how can you limit the use of global administrators. So where can you find all the Azure AD admin roles? You can go to your Azure Active Directory and click on Roles and Administrators. First, let's talk about global administrators. And first thing we need to understand about global administrator is how can you limit the use of global administrator role. Users who are assigned to the global administrator role can read and modify every administrative settings in your Azure AD organization. By default, the person who signs up for the Azure subscription is assigned the global administrative role for the Azure AD organization. Only global administrators and privileged role administrators can delegate administrative roles. To reduce the risk to your business, I recommend that you assign this role to the fewest possible people in your organization. So if you have more than 5 administrative roles in your organization, I will help you understand how you can reduce this by adding these users into different roles. The first one is application administrator. Users in this role can create and manage all aspects of enterprise application registrations, and application proxy settings. Let's understand what is authentication administrator role. Users with this role can set or reset non-password credentials for some users and can update passwords for all users. Then we have Azure DevOps Administrator. Users with this role can manage the Azure DevOps policy to restrict new Azure DevOps organization creation to a set of configurable users or groups. Azure Information Protection Administrator have all permission in Azure Information Protection Service. B2C IEF Keyset Administrator and B2C IEF Policy Administrators can create and manage policy key and secrets for token encryption. And similarly, the Policy Administrator can create, read, update, delete all custom policies in Azure AD B2C. Another important role we need to understand is about Billing Administrator. Billing administrators are the one who makes purchases, manages subscriptions, manages support tickets, and monitors service health. One another important role we need to understand is all about Cloud Device Administrator. Users in this role can enable, disable, and delete devices in Azure AD and read Windows 10 BitLocker keys in the Azure portal as well. The users in the Compliance Administrative role have permissions to manage compliance-related features in Microsoft 365 Compliance Center. And users in the Conditional Access Administrative role have the ability to manage Azure Active Directory Conditional Access settings. Once again, the most important role is Global Administrator. So don't go ahead and assign Global Administrator for everyone in your organization. Users with this role have all access to all administrative features in your Azure Active Directory, as well as services that use Azure AD identities like Microsoft 365 Security Center, Microsoft 365 Compliance Center, Exchange Online, SharePoint Online, and Teams as well. Let's understand what is Azure Active Directory Domain Services. Azure Active Directory Domain Services provide managed domain service such as domain join, group policy, Lightweight Directory Access Protocol or LDAP, and Kerberos or NTLM authentication that is fully compatible with Windows Server Active Directory. You use these domain services without the need to deploy, manage, and patch domain controllers in the cloud. Azure AD DS integrates with your existing Azure AD tenant. Azure AD Domain Services integrates with your existing Azure AD tenant, which makes it possible for users to sign in with your existing credentials. You can also use existing groups and user account to secure access to resources, which provides a smoother lift and shift of your on-premises resources to Azure. And Azure AD DS replicates identity information from your Azure AD, so it works with your Azure AD tenants that are cloud only or synchronized with your on-premises Active Directory domain services environment. The same set of Azure AD DS features exist for both environments. So if you have an existing on-premises ADDS environment, you can synchronize user account information to provide a consistent identity for users. For cloud-only environments, you don't need a traditional on-premises ADDS environment to use the centralized identity services of Azure ADDS. So let us understand some of the Azure AD Domain Services features and benefits. First of all, to deploy Azure ADDS, it is super simple and the deployment experience is super seamless. Azure ADDS is enabled for your Azure AD tenant using a single wizard in your Azure portal. And Azure ADDS integrates with your Azure AD as well. User accounts, group memberships, and credentials are automatically available from your Azure AD tenant. With Azure ADDS, you can use your corporate credentials and passwords as well. Passwords for users in ADDS are same as in your Azure AD tenant. Users can use their corporate credentials for domain join machines, sign in interactively over remote desktop, and authenticate against Azure AD Domain Services Managed Domain as well. Another great feature and benefit why many people look into Azure ADDS is the ability to use NTLM and Kerberos authentication. With the support for NTLM and Kerberos authentication, you can deploy applications that rely on Windows integrated authentication. And finally, why many people look into Azure ADDS is because of the high availability. Azure ADDS includes multiple domain controllers, which provide high availability for your managed domain. This high availability guarantees service uptime and resilience to failures. In regions that support Azure availability zones, these domain controllers are also distributed across zones for additional resiliency. Please note that Azure AD Domain Services integrates with your Azure AD, which itself can synchronize with your on-premises ADDS environment as well. This ability extends central identity use cases to traditional web applications that run in Azure as part of your lift and shift strategy. Now let us understand what is Azure AD Users and what are the different types of users available in Azure AD. In Azure AD, every user who needs access to resources need a user account. A user account is a synchronized Active Directory domain services object or Azure AD user object that contains all information needed to authenticate and authorize the user during the sign-on process and to build the user's access token. So how can you view Azure AD Users? Go to your Azure subscription. Under Azure subscription, click on Azure Active Directory and you can view all the users by clicking on Users. So this is where you can see all the users in your Azure AD. You can see that there is a user type. You can see that you can see the username and the user principal name. Username include the name or the display name of the user, and the user principal name includes their email addresses. Then we have the user type. User type will give us an indication that whether this user is a member or a guest user. Then we have another filter which is all about is it a directory synchronized or not. Directory synchronized means that user came from an on-premises domain controller. If it is not, that means that these users are a cloud-bound user. Typically, Azure AD defines users in three ways. The first one is cloud identities. These users exist only in Azure AD or cloud-bound users. Examples are administrator accounts and users that you manage yourself. Their source is Azure AD. The second type is directory synchronized identities. These users exist in on-premises Active Directory. A synchronization activity that occurs via Azure AD Connect brings these users into Azure. And the third type is guest users. These users exist outside Azure. Examples are accounts for other cloud providers and Microsoft account. Now let's understand Azure AD group accounts. Azure AD allows you to define two different types of groups. So first, let me show you where you can find Azure AD groups. I'm on my Azure portal. So within your Azure Active Directory, under Manage, you can go to Groups. There are two different types of groups available. One is Security Group. Another one is Office 365 or Microsoft 365 groups. So let me show you how you can create a group. When you try to create a group, you have two options. The first one is Security Groups. Security groups are the most common, and these are used to manage members and computer access to shared resources for a group of users. For example, you can create a security group for a specific security policy. By doing it this way, you can give a set of permission to all the members at once instead of having to add permission to each members individually. This option requires an Azure AD administrator. The second option is Microsoft 365 groups. These groups provide collaboration opportunity by giving members access to a shared mailbox, calendar, files, SharePoint sites, and more. This option also lets you give people outside of your organization access to the group as well. And this option is available to users as well as admins. While talking about groups, there are different ways you can assign membership as well. We have assigned dynamic user and dynamic device as well. So let's understand what are these in detail. Assigned lets you add specific users to be member of this group and have unique permissions. A dynamic user lets you use dynamic membership rules to automatically add or remove members. And the third way of creating group is by using dynamic device. Dynamic device lets you use dynamic group rules to automatically add and remove devices. Alright, so now it's time for us to learn about Azure Multi-Factor Authentication. Azure Multi-Factor Authentication helps safeguard access to data and applications while maintaining simplicity for users. It provides additional security by requiring a second form of authentication and delivers strong authentication through a range of easy-to-use authentication methods. For organizations that need to be compliant with industry standards such as PCI, DSS, MFA is a must-have capability to authenticate users. Beyond being compliant with industry standards, enforcing MFA to authenticate users can also help organizations to mitigate credential theft and attacks. The security of MFA two-step verification lies in its layered approach. Compromising multiple authentication factors presents a significant challenge for attackers. Even if an attacker managed to learn the user's password, it is useless without also having possession of the additional authentication methods. And these additional authentication methods include something you know, which is typically a password, something you have, which is a trusted device that is not easily duplicated like a phone, and something you are, which is biometrics. So now let us have a look at what are the MFA's key features. Azure MFA helps safeguard access to data and application and helps to meet customer demand for a simple sign-in process. You can get strong authentication with a range of easy verification options like phone call, text message, or mobile app notification, and allows customers to choose the method they prefer. The second feature we need to understand is MFA mitigate threats with real-time monitoring and alerts. MFA helps protect your business with security monitoring and machine learning-based reports that identify inconsistent sign-in patterns. To help mitigate potential threats, real-time alert notify your IT department of suspicious account credentials. The third feature is you can use MFA to deploy on-premises or on Azure as well. You can use MFA server on your on-premises to help secure VPNs, Active Directory Federation services, IIS website application, remote desktop, and other remote access applications using Radius and LDAP authentication as well. You can add extra verification step to your cloud-based application and services by just turning on multi-factor authentication in your Azure Active Directory. And the fourth feature I would like to highlight is you can use MFA with your Office 365 and plenty other SaaS-based applications. MFA for Office 365 help you secure access to your Office 365 application at no additional cost. Multi-factor authentication is also available with Azure Active Directory Premium and thousands of software as a service applications including Salesforce, Dropbox, and other popular services. And the last feature I would like to highlight is you can add MFA protection for Azure administrative accounts. MFA adds a layer of security to your Azure administrative accounts at no additional cost. When it's turned on, you need to confirm your identity to create a virtual machine, manage storage, or other Azure services as well. Now let me show you how you can access multi-factor authentication and where you can find all the settings to turn on, enable, or disable these, and how you can find these multi-factor authentication options as well. So I'm on my Azure portal. Click on Azure Active Directory. Within Azure AD, go to Users. Under Users tab, go click on Multi-Factor Authentication Settings over here. And this takes you to a totally different portal for authentication settings and service settings. This is the page where you would be able to view all the sign-in allowed users, who are the billing administrator, global administrators, etc. And this is a quick way to find out who you had enabled multi-factor authentication in your organization and who you have enforced, etc. Under service settings is where you would be able to find all the settings related to multi-factor authentication. Let's talk about verification option first. Under multi-factor authentication verification option, we have 4 methods. Let's go by one. The first one is call to phone. When you select call to phone, this places an automated voice call. The user answers the call and presses hash in the phone keypad to authenticate. The phone number is not synchronized to your on-premises Active Directory. A voice call to the phone is important because it persists through a phone handset upgrade, allowing the user to register the mobile app on your new device. The second option is text message to phone. This option sends a text message that contains a verification code. The user is prompted to enter the verification code into a sign-in interface. This process is called one-way SMS. The third verification option is notification through mobile app. Notification through mobile app sends a push notification to your phone or a registered device. The user views the notification and selects Approve to complete the verification. The Microsoft Authenticator app is available for your Android and iOS, and this push notification through the mobile app provides the best user experience. And the fourth verification process is verification code from mobile app. The Microsoft Authenticator app generates a new OAuth verification code every 30 seconds. The user enters the verification code into the signing interface. Please note that there is also a section to cache password so that users do not have to authenticate on trusted devices. The number of days before a user must re-authenticate on trusted device can also be configured in the value from 1 to 365 days. So what are the other multi-factor authentication settings available? So I'm going to go back to my Azure portal. Under your Azure Active Directory, on the left-hand side, under Manage, go to Security. Within Security, you would be able to find multi-factor authentication or MFA. So click on MFA. Under MFA, there are a few settings you need to understand. Those are account lockout, block or unblock users, fraud alert, notification, or auth tokens, phone call systems and providers. So let me help you understand what are these. The first one is account lockout. This setting helps you prevent repeated MFA attempts as part of an attack. The account lockout setting lets you specify how many failed attempts to allow before the account becomes locked out for a period of time. The account lockout settings are only applied when a PIN code is entered for an MFA prompt. Some of the settings which is available under the account lockout are number of MFA denials to trigger account lockout, minutes until account lockout counter is reset, and minutes until an account is automatically unblocked. The second setting is block and unblock users. If a user's device has been lost or stolen, you can block authentication attempts for the associated account. The next setting is fraud alerts. Within fraud alerts, we have two options. You can configure the fraud alert feature so that your users can report fraudulent attempts to access the resource. Users can report fraud attempts by using the mobile app or through their phone as well. And users can use a code to report a fraud during an initial greeting as well. When users receive a phone call to perform two-step verification, they normally press hash to confirm their sign-in. To report fraud, the user enters the code before pressing hash. This code is 0 by default, but you can customize it based on your requirement. Another setting is notification. Email notification can be configured when users report fraud alerts. These notifications are typically sent to identity administrators, as the user account credentials are likely compromised. The next setting we need to understand is about OAuth tokens. Azure AD supports the use of OAuth tokens that refreshes code every 30 to 60 seconds. And customers can purchase their tokens from the vendor of their choice as well. The last settings you need to understand is about trusted IPs. Trusted IP is a feature to allow federated user or IP address range to bypass two-step authentication. Please note that the trusted IP bypass works only from inside of your company internet. If you select the all federated user option and user signs in from outside of your company intranet, the user must authenticate it by using two-step verification. Alright, so that concludes this lesson. In the next video, we're going to start a brand new episode. And in this episode, we will learn about Azure AD Identity Protection. Let me show you on a high level what are the topics we are going to touch on this video. We will start with what is Azure AD Identity Protection, how can you access these risk events, and how can you define these user risk policy and sign in risk policy. We will dive deep into what is Azure AD Conditional Access and how you can set up your own CA, and what are these conditions and where are these conditions applied to. And finally, we finish off with access reviews. So without wasting any more time, let's get into it. So what is Azure AD Identity Protection? Identity protection is a tool that allows organizations to accomplish three key tasks. First is automate the detection and remediation of identity-based risk. Then it does investigate risk using data in the portal. And the third task is exporting the risk detection data to third-party utilities for further analysis. Identity protection uses the learnings Microsoft has acquired from their position in organizations with Azure AD, the consumer space with Microsoft accounts, and in gaming with Xbox to protect your users. Microsoft analyzes 6.5 trillion signals per day to identify and protect customers from threats. Risk detections in Azure AD Identity Protection include any identified suspicious actions related to user account in the directory. The signals generated that are fed to identity protection can be further fed into tools like Conditional Access to make access decisions, or fed back to security information and even management SIM tools for further investigation based on your organization's enforced policies. So let's first understand what is identity protection policies. So let's first understand what are the three default policies available for identity protection. Azure AD Identity Protection includes three default policies that administrators can choose to enable. These policies include limited customization but are applicable to most organizations. So first, let me show you how you can access these policies. Go to your Azure AD and under Security, Click on Identity Protection. And this is where you can see these three policies. All the policies allow for excluding users such as your emergency access or break glass administrator accounts. So first, let's talk about Azure MFA registration policy. Identity protection can help organizations roll out Azure multi-factor authentication using conditional access policy requiring registration at sign-in. Enabling this policy is a great way to ensure new users in your organization have registered for MFA on their first day. Multi-factor authentication is one of the self-remediation method for risk event within identity protection. Self-remediation allows for users to act on their own to reduce help desk call volume. The second policy we need to understand is sign-in risk policy. Identity protection analyzes signals from each sign-in, both real-time and offline, and calculates a risk score based on the probability that the sign-in wasn't performed by the user. Administrators can choose to block access, allow access, or allow access but require multi-factor authentication. If risk is detected, users can perform multi-factor authentication to self-remediate and close the risk sign-in event to prevent unnecessary noise for administrators. And the third type is custom conditional access policy. So administrators can also choose to create a custom conditional access policy, including sign-in risk as an assignment condition. Let's understand what are risk events. The majority of security breaches take place when attackers gain access to an environment by stealing a user's identity. Discovering compromised identities is not an easy task. Azure Active Directory uses adaptive machine learning algorithms and heuristics to detect suspicious actions that are related to your user accounts. Each detected suspicious action is stored in a record called risk detections. There are two places where you can review these reports. One is under Azure AD reporting and the second is under Azure AD identity protection. Let me show you how you can access this in Azure AD reporting. I'm going to go back to my primary Azure AD. You can go under this Azure AD reporting to risk to find the risk detections, which is part of your Azure AD security reports. In addition, you can use Identity Protection Risk Detection API to gain programmatic access to security detection using Microsoft Graph as well. Currently, Azure Active Directory detects 6 types of risk detection. First one is users with leak credentials. When cyber criminals compromise valid passwords of legitimate users, they often share those credentials. Second type of risk is sign-in from anonymous IP addresses. This risk detection type identifies users who have successfully signed in from an IP address that has been identified as an anonymous proxy IP address. Third type is impossible travel to atypical locations. This risk detection type identifies 2 sign-ins originating from geographically distant locations, where at least one of the locations may also be atypical for user given past behavior. Another risk type is sign-in from unfamiliar locations. This risk detection type considers past sign-in location, which is IP address, latitude, longitude, and ASN, to determine new or unfamiliar locations. Next risk type is sign-in from infected devices. This risk detection type identifies sign-ins from devices infected with malware that are known to actively communicate with a bot server. And the last risk type is sign-in from IP addresses with suspicious activity. This risk detection type identifies IP addresses from which a high number of failed sign-in attempts were seen across multiple user accounts over a short period of time. Please note that while the detection of risk detections already represent an important aspect of protecting your identities, you also have the option to either manually address them or implement automated responses by configuring conditional access policies. So let me show you an example of a user risk policy. Identity protection can calculate what it believes is normal for user behavior and use that to base decisions of their risk. User risk is a calculation of probability that an identity has been compromised. Administrators can decide based on their risk score signal to enforce organizational requirements. Administrators can choose to block access, or allow access but require a password change using Azure AD self-service password reset. This is an example of an image shows the configuration of user risk policy applied. With the information provided by the risky user report, administrators can find which users are at risk and have had risk remediated or have had risk dismissed as well. This can give you more details about detection, history of all risky sign-in and risk history as well. And what are the actions administrators can do? Administrators can then choose to act on these events and decide to do reset of the user password, confirm to the user that user account is compromised, or they can simply dismiss the user account, or they can simply dismiss the user risk, or block user from sign-in, or investigate further using Azure ATP. Next, I want to show an example of a sign-in risk policy. Sign-in risk represents the probability that a given authentication request isn't authorized by the identity owner. For users of Azure Identity Protection, sign-in risk can be evaluated as part of a conditional access policy. So what are the conditions which sign-in risk policy support? First, it supports location and client app and risky sign-in. With the information provided by the risky sign-in report, administrators can get real-time and aggregate risk levels associated with sign-in attempts. They can find out the detection type triggered, MFA details, device information, application information, location information, etc. Alright, so now let's go and understand what is Azure AD Conditional Access. Conditional Access is the tool used by Azure Active Directory to bring signals together to make decisions and enforce organizational policies. Conditional access is at the heart of the new identity-driven control plane. Conditional access policy is really a next-generation policy that built for the cloud. It's able to consider massive amounts of data as well as a contextual data from a user sign-in flow and make sure that the right controls are enforced. So before we go ahead and understand more about conditional access, I want to help you understand what is identity as a service. Identity as a service is the new control plane. First, let's understand what is a control plane. In a switch or router, the control plane is the part that controls where the traffic is to go, but it's not responsible for the movement of the traffic. The control plane learns the routes, which is either static or dynamic. The part responsible for moving the traffic is the forward plane. And this is an example of a figure which shows the simple switch diagram. And user identity is like the control plane because it controls which protocols the user will interact with organizational programs that user can access, and which devices the users can access, and what programs. Identity is what helps protect user and corporate data. For example, should that the data be encrypted, deleted, or ignored when an issue occurs? So by using the conditional access policies, you can apply the right access control when needed to keep your organization secure and stay out of your users' way when not needed. And these conditional access policies are enforced after the first factor authentication has been completed. And the conditional access is not intended as an organization's first line of defense for scenarios like denial of service, which is a DOS attack, but can use signals from these events to determine access. Please note that conditional access is an effective way to enable access to resources after specific conditions have been met. Let us now understand what are these conditions. First, let me show you where you can find your conditional access. I'm on my Azure portal. Go to Security and click on Conditional Access. By default, you can find a couple of policies. You can click on New Policy. By default,
Conditional access comes with 6 conditions: user or group, cloud application, device state, location IP address range, client application, and sign in risk. You can use the combination of these conditions to get the exact conditional access policy you need. Notice that in this example image, the conditions determine the access control to allow access to the application, or is it to blocking the application. With access control, you can either block access altogether or grant access with the additional requirement by selecting the desired controls as well. Please note that the users and groups condition is mandatory in a conditional access policy. In your policy, you can either select all users or specific users or groups. Now let's understand what is access reviews. Azure AD Access Reviews enable organizations to effectively manage group memberships, access to enterprise application, and role assignments. User access can be reviewed on a regular basis to make sure only the right people have continued access. And you might wonder, why are access reviews important? So before I explain why are access reviews important, let me show you where you can access it. You can go to search box and type in identity governance and select that. Azure AD enables you to collaborate internally and with users external to your organization as well, such as your partners. Users can join groups, invite groups, connect to cloud apps, and work remotely from their work or personal devices. You can use access reviews for some of the use cases. Let me explain these use cases. The first use case where you can use access reviews are if you have too many users in privileged roles, access reviews are going to be a best fit. It is a good idea to check how many users have administrative access and how many of them are global administrators. And if there are any invited guests or partners that have not been removed after being assigned to do an administrative task. The second use case is when automation is infeasible. You can create rules for dynamic membership on security groups or Office 365 groups. But what if the HR data is not in Azure AD, or if users still need to access after leaving the group to train their replacement? You can then create a review on that group to ensure those who still need access should have continued access. Another use case is when a group is used for a new purpose. If you have a group that is going to be synced to Azure AD, or if you plan to enable a sales management application for everyone in the sales team, it would be useful to ask the group owner to review the group membership prior to the group being used in a different risk context. Another use case is business critical data access. For certain resources, it might be required to ask people outside of IT to regularly sign out and give a justification on why they need access for auditing purposes. Another way you can use access reviews are to maintain a policies exception list. In an ideal world, all users would follow the access policies to secure access to your organizational resources. However, sometimes there are business cases that require you to make exceptions. As the IT admin, you can manage this task, avoid oversight of policy exception, and provide auditors with proof that these exceptions are reviewed regularly. Next use case is asking the group owners to confirm they still need guests in their groups. Employee access might be automated with some on-premises IAM, but not invited users. If a group gives guest access to business-sensitive content, then it's the group owner's responsibility to confirm the guests still have the legitimate business need for access. The last use case is have reviews recur periodically. You can set up recurring access reviews of users at set frequencies such as weekly, monthly, quarterly, or annually, and the reviewers will be notified at the start of each review. And reviewers can approve or deny access with a friendly interface and with the help of smart recommendations. All right, so that concludes identity protection lesson. In the next video, we are starting episode 4. In episode 4, we are going to learn about enterprise governance. Let's have a look at the high level things what we are going to learn on this video. We will understand what's the shared responsibility model between a customer and Microsoft. We will go through what are the Azure cloud security advantages. We will understand how Azure hierarchy looks like and how can you use Azure policies to manage multiple subscription or things within your subscription as well. Azure role-based access control is very important to understand in terms of user management and role-based management. And how is Azure RBAC different from Azure policies? We will touch upon what are the built-in roles available within Azure and how can you implement resource locks to prevent anyone from modifying or deleting any existing resources. We will learn about Azure blueprints and some of the Azure subscription management as well. So without wasting any more time, let's get into it. First, let's understand what is a shared responsibility model. Organizations face many challenges with securing their data centers, including recruiting and keeping security experts, using many security tools, and keeping pace with the volume and complexity of threats. As cloud computing environments move from customer controlled data center to the cloud, the responsibility of the security also shifts. Security of the operational environment is now a concern shared by both cloud providers and customers. By shifting these responsibilities to a cloud service like Azure, organizations can reduce focus on activities that aren't core business competencies. The first thing to understand about cloud security is that different scopes of responsibility exist depending on kind of services you use. For example, if you use virtual machines in Azure, which provide infrastructure as a service, Microsoft will be responsible for helping secure the physical network, physical storage, and virtualization platform, which includes updating the virtualization host, etc. But you will need to take care of helping secure your virtual network and public endpoints and updating the guest operating system of your VMs, etc. This is a following figure shown as an example which shows the various responsibility zones. For all cloud deployment types, you own your data and identities. You are responsible for helping secure your data and identities. Your on-premises resources and cloud components you control. Regardless of the deployment type, you always retain responsibility of data, endpoints, account, and access management. It's important to understand the division of responsibility between you and Microsoft in a software as a service, platform as a service, or infrastructure as a service deployment. Let's understand the cloud security advantage in terms of Azure. The cloud offers significant advantages for solving long-standing information security challenges. In an on-premises environment, organizations likely have unmet responsibilities and limited resource availability to invest in security, which creates an environment where attackers can exploit vulnerabilities at all layers. This is a following example diagram which shows a traditional approach where many security responsibilities are unmet due to limited resources. In the cloud-enabled approach, you can shift day-to-day security responsibility to your cloud provider and reallocate your resources. And in the cloud-enabled approach, you are also able to leverage cloud-based security capabilities for more effectiveness and use cloud intelligence to improve your threat detection and response time. By shifting responsibility to the cloud provider, organizations can get more security coverage, which enables them to reallocate security resources and budget to other business priorities. So let's understand Azure hierarchy. Within Azure hierarchy, first topic we are going to learn is all about Azure Resource Manager. Azure Resource Manager, or ARM, is the deployment and management service for Azure. It provides a consistent management layer that allows you to create, update, and delete resources in your Azure subscription. You can use its access control, auditing, and tagging features to help secure and organize your resources after deployment. When you take actions through the portal, Azure PowerShell, the Azure CLI, the REST API, or SDKs, The Resource Manager API handles your request. The Azure Resource Manager uses APIs and authentication to allow access to all the resources. Now let's understand scope. Azure provides 4 levels of scope: management group, subscriptions, resource groups, and resources. So all the blue cubes represent resources. You apply management setting at any of these level of scope. The level you select determines how widely the setting is applied. Lower levels inherit settings from higher levels. For example, when you apply a policy to the subscription, the policy is applied to all resource group and resources in your subscription. And when you apply a policy on the resource group, that policy is applied to the resource group and all its resources. However, another resource group doesn't have that policy assignment. You can deploy templates to management groups, subscription, or resource groups. So there are some important factors to consider when defining your resource group. All the resources in your group should share the same life cycle. You deploy, update, and delete them together. If one resource, such as a database server, need to exist on a different deployment cycle, it should be on another resource group. Each resource can only exist in one resource group. Another important factor is you can add or remove a resource to a resource group at any time. And you can move a resource from one resource group to another resource group as well. Another key aspect to remember is a resource group can contain resources that are located in different regions. And a resource group can be used to scope access control for administrative actions as well. Now let's understand what is a management groups. Management groups are an Azure resource to create flexible and very maintainable hierarchies within the structure of your environment. Management group exists above the subscription level, thus allowing subscription to be grouped together. This grouping allows applying policies and RBAC permissions to those management groups. Policies and RBAC permissions are inherited to all resources in the management group. And management group give you enterprise grade management at large scale, no matter what type of subscription you might have. All subscriptions within a single management group must trust the same Azure Active Directory tenant. And management group hierarchies can be up to 6 levels deep. This provides you with the flexibility to create a hierarchy that combines several of these strategies to meet your organizational needs. So let's look at the example diagram here. This shows an organizational hierarchy that combines a business unit strategy with a geographic strategy. Let's understand some of the value of management groups. The first one is management groups allow you to group your subscription together. This will give you ability to provide user access to multiple subscription, allows for new organizational models and logically grouping of resources, allows for single assignment of control that applies to all subscriptions, and provides aggregated views above the subscription level as well. Another value which management group brings in is this will give you an ability to mirror your organizational structure. This ability allows you to create a flexible hierarchy that can be updated quickly, and the hierarchy does not need to model the organizational billing hierarchy, and this structure can easily scale up or down depending on your need as well. And the third value is ability to apply policies or access controls to any services. With this ability, you can create one RBAC assignment on the management group, which will inherit that access to all the subscriptions. And you can use Azure Resource Manager integration that allows integration with other Azure services like Azure Cost Management, Privileged Identity Management, and Azure Security Center. By using this management group, you can reduce your workload and reduce the risk of error by avoiding duplicate assignments. Instead of applying multiple assignments across numerous resources and subscriptions, you can apply the one assignment on the one management group that contains the target resources. This will save time in the application of assignments, creates one point for maintenance, and allows for better controls on who can control the assignment. The next topic is Azure Policies. Azure Policy is a service you use to create, assign, and manage policies. These policies enforce different rules and effects over your resources so that those resources can stay compliant with your corporate standards and service level agreements. Azure Policy meets this need by evaluating your resources for non compliance with assigned policies. For example, you might have a policy that allows virtual machines of only a certain kind in your environment. After this policy is implemented, new and existing resources are evaluated for compliance. With the right type of policy, existing resources can be brought into compliance as well. These are the three main pillars in the functionality of Azure Policy. The first pillar is around real time enforcement and compliance assessment. For example, a policy would block the creation of resources that are located outside of US regions. The second pillar of policy is applying policies at scale by leveraging management groups. By assigning policy to a management group, one can impact hundreds of subscriptions, and all of these resources can be reached through a single policy assignment. And the third pillar of the policy is remediation by leveraging a remediation policy. This will automatically remediate the non-compliant resources so that your environment always stay compliant. So let me take you to the Azure portal to show you how to access these Azure policies. You can search for Azure policies in the global search box and click on policies, and you would be able to see all the policies which you have assigned, whether your policies are staying compliant state, and you can click on view all to see all the policies and the assignments what you have done on your subscription as well. Let's understand how can you compose an Azure policy. There are three steps in composing and implementing an Azure policy. Those are policy definition, policy assignment, and policy parameters. Every policy definition has conditions under which it enforced, and it has a defined effect that takes place if the conditions are met. In policy assignment, a policy definition that has been assigned to take place within a specific scope. This scope could range from a management group to an individual resource. The term scope refers to all the resources, resource groups, subscriptions, or management groups that the policy definition is assigned to. And the third step is policy parameters. They help simplify your policy management by reducing the number of policy definition you must create. You can define parameters when creating a policy definition to make it more generic. So what are Azure Role-Based Access Control or RBAC? When it comes to identity and access, most organizations that are considering using the public cloud are concerned about two things: ensuring that when people leave the organization, they lose access to resources in the cloud, and striking the right balance between autonomy and central governance. RBAC is an authorization system built on Azure Resource Manager that provides fine-grained access management of Azure resources. Azure AD and role-based access control make it simple for you to carry out these goals. After you extend your on-premises Active Directory to the cloud by using Azure AD Connect, your employees can use and manage their Azure subscription by using their existing work identities. These Azure subscriptions automatically connect to Azure AD for single sign-on and access management. When you disable an on-premises Active Directory account, it automatically loses access to all Azure subscriptions connected with Azure AD. And RBAC enables fine-grained access management for Azure as well. Using RBAC, you can grant just the amount of access that users need to perform their jobs. This example here shows a classic subscription administrator role, RBAC role, and Azure AD administrator roles are related at a high level. Roles assigned at a higher scope, like subscription, are inherited by child scopes, like service instances. Please note that a subscription is associated with only one Azure AD tenant. So how is Azure RBAC different from Azure Policies? There are a few key differences between Azure Policy and RBAC. RBAC focuses on user actions at different scope. You might be added to the contributor role for a resource group, and that allowing you to make changes to the resource group. wherein Azure Policy focuses on resource properties during deployment and for already existing resources. Azure Policy controls properties such as types or location of resources. Unlike Airbag, Azure Policy is a default allow and explicit deny system. And RBAC and policies in Azure play a vital role in governance strategy. While both are so different, but they both work together to ensure organizational business rules are followed by ensuring proper access and resource creation guidelines are met. Let's understand what are Azure built-in roles. Azure Role-Based Access Control have several Azure built-in roles that you can assign to users, groups, service principals, and managed identities. Role assignments are the way you control access to Azure resources. If the built-in roles doesn't meet the specific need for your organization, you can create your own custom roles as well. Basically, there are 4 general built-in roles. Let me show you where you can find that. Under Azure portal, you go under subscriptions and click on Access Control IAM. You go under role assignments, click on add role assignment, and basically there are different roles available. But primarily, there are 4 roles you need to be aware of. First one is owner. This lets you manage everything, including access to resources. Second is contributor. Contributor lets you manage everything except granting access to resources. Then there is reader. Reader role lets you view everything but not make any changes. And the 4th role is user access administrator. This lets you manage user access to Azure resources. And like I said, there are custom roles as well. If the built-in roles for Azure resources doesn't meet the specific need in your organization, you can create your own custom roles. And the custom roles can be shared between subscription that trust the same Azure AD directory as well. Let's understand what are resource locks. As an administrator, you may need to lock a subscription, resource group, or resource to prevent other users in your organization from accidentally deleting or modifying critical resources. You can set the lock level to cannot delete or read only. So let me show you in the portal how you can lock resources. I'm on my Azure portal. I'm going to go to resource group. I'm going to pick a sample resource group. Under settings, you can see that there is lock. Right now, there is no lock applied, but when I click add, it gives me an option to give a name to the lock. And there are basically 2 types of locks, delete and read only. So let's talk about the delete one. The cannot delete or delete means authorized users can still read and modify a resource, but they can't delete the resource. The read only means authorized users can read a resource, but they can't delete or update the resource. Applying this lock is similar to restricting all authorized users to the permissions granted by the reader role. Once the resource has been locked, the resource lock must first be removed before the resource can be modified or deleted. Now let's understand what are Azure blueprints. Just as a blueprint allows an engineer or an architect to sketch a project's design parameters, Azure blueprints enables cloud architects and central information technology group to define a repeatable set of Azure resources that implements and adheres to an organizational standards, patterns, and requirements. Azure Blueprints makes it possible for development teams to rapidly build and stand up new environments. And blueprints are a declarative way to orchestrate the deployment of various resource templates and other artifacts such as role assignments, policy assignments, Azure Resource Manager templates, and resource groups. The Azure Blueprint service is backed by the globally distributed Azure Cosmos DB. The blueprint objects are replicated to multiple Azure regions, and the replication provides low latency, high availability, and consistent access to your blueprint objects. So how is it different from Resource Manager templates? There is no need to choose between a Resource Manager template and a blueprint. Each blueprint can consist of 0 or more resource group template artifacts. This support means that previous effort to develop and maintain a library of Resource Manager templates are reusable in blueprints. So, how is it different from Azure Policy? Including a policy in a blueprint enables the creation of the right pattern or design during assignment of the blueprint. The policy inclusion makes sure that only approved or expected changes can be made to the environment to protect ongoing compliance to the intent of the blueprint. Okay, now let's talk about Azure Subscription Management. An Azure Active Directory tenant is created for you when you sign up for Azure. The tenant represents your account, and you can use the tenant to manage access to your subscription and resources. When you create a new subscription, it's hosted in your account's Azure AD tenant. If you want to give others access to your subscription or its resources, you need to invite them to join your tenant. By doing so, this helps you control access to your subscription and resources. You can create additional subscription for your account in Azure. You might want an additional subscription to avoid reaching subscription limit, to create separate environment for billing and security, or to isolate data for compliance reasons. An Azure Active Directory tenant is created for you when you sign up for Azure. The tenant represents your account, and you can use the tenant to manage access to your subscription and resources. Alright, so now let's understand how to manage API access to Azure subscription and resources. When you publish APIs through API management, it's easy and common to gain access to those API by using subscription keys. Client applications that consume the published API need to include a valid subscription key in HTTP request when they make calls to those API. To get a subscription key for accessing APIs, a subscription is required. API management support additional mechanisms for gaining access to APIs, including OAuth 2.0, client certificates, and IP allow list. And who can transfer a subscription? A billing administrator or the account administrator is a person who has permission to manage billing for an account. They are authorized to access billing on your Azure portal and do various billing tasks like create subscription, view and pay invoices, or update payment methods. Alright, so that concludes Enterprise Governance module. In the next video, we're going to learn about Azure AD Privileged Identity Management. Let's have a high-level look at what are the things we are going to learn on this video. We will start with understanding what is Microsoft Zero Trust model, what is Microsoft Identity Management and how it evolved, and what are privileged identity management features, scope, and how can you onboard privileged identity management. And we will talk about what are the PIM configuration settings and the workflow. Without wasting any more time, let's get into it. So what is a zero trust model? A zero trust model states that you should never assume trust, but instead continually validate trust. When users, devices, and data all resided inside the organization's firewall, they were assumed to be trusted. This assumed trust allowed for easy lateral movement after a malicious hacker compromised an endpoint device. Instead of assuming everything behind the corporate firewall is safe, the zero trust model assumes breach and verifies each request as though it originates from an open network. Regardless of where the request originates or what resources it accesses, zero trust teaches us to never trust and always verify. Every access request is fully authenticated, authorized, and encrypted before granting access. Microsegmentation and least privileged access principles are applied to minimize lateral movement. Rich intelligence and analytics are utilized to detect and respond to anomalies in real time. With most users now accessing application and data from the internet, most of the components of the transaction, that is the users, network, and devices, are no longer under organizational control. The zero trust model relies on verifiable user and device trust claims to grant access to organizational resources. No longer is the trust assumed based on the location inside an organization's perimeter. This is a quick diagram to show you the basic components of the zero trust model. Notice that there are some components which is determining this trust. So let me take you through these one by one. What is an identity provider? Identity provider establishes a user's identity and related information. And what is device directory? Device directory validates a device and device integrity. The next trust determination is policy evaluation service. This determines whether the user and device conform to use. This determines whether the user and device conform to security policies. And the last trust determination is access policy. Access policy determines which organizational resources can be accessed. So let's learn about how can you implement a zero trust security model. Migrating to a zero trust security model provides for a simultaneously improvement of security over conventional network based approaches and to better enable users where they need access. A zero trust model requires signals to inform decisions, policies to make access decisions, and enforcement capabilities to implement those decisions effectively. The user is the common denominator of these components. That's why a user identity and how that identity is managed is now called the control plane. If you can't determine who the user is, you can't establish a trust relationship for other transactions. So, what are the guiding principles of zero trust model? The first one is how can you verify explicitity? So, let's look at the guiding principles of zero trust. The first principle we are going to look is called verify explicitly. Always authenticate and authorize based on all available data points, including user identity, location, device health, service or workload, data classification, and anomalies. The second principle is use the least privileged access. Limit user access with just in time and just enough access. Risk based adaptive policies and data protection to protect both data and productivity. And the third guiding principle is always assume breach. Minimize blast radius for breaches and prevent lateral movement by segmenting access by network, user, devices, and application awareness. Verify all sessions are encrypted end to end. Use analytics to get visibility, drive threat detection, and improve defenses. So now let's have a look at Microsoft Zero Trust architecture. So this example is a simplified reference architecture for our approach to implementing Zero Trust. So this is a simplified reference architecture example from Microsoft to implement the Zero Trust. The primary components of this process are use Intune for device management and device security policy configuration, use Azure AD Conditional Access for device health validation, and Azure AD for user and device inventory. The system works with Intune, pushing device configuration requirements to manage devices. The device then generates a statement of health, which is stored in Azure AD. And when the device user requests access to a resource, the device health state is verified as part of the authentication exchange with Azure AD. When the user requests access to a resource, the device health state is verified as part of the authentication exchange with Azure AD. Now let's understand what is Microsoft Identity Management. Microsoft Identity Manager or MIM helps organizations manage the users, credentials, policies, and access within their organization and hybrid environments. With MIM, organizations can simplify identity lifecycle management with automated workflows, business rules, and easy integration with heterogeneous platforms across the data center. MIM enables Active Directory to have the right users and access rights for on-premises apps. Azure AD Connect can then make those users and permissions available in Azure AD for Office 365 and cloud-hosted apps. Identity has become the common factor among many services like Microsoft Office 365 and Xbox Live, where the person is the center of the services. Identity is the new security boundary, the new firewall, the new control plane, whichever the comparison you prefer. Your digital identity is the combination of who you are and what you are allowed to do. That is called credentials plus privileges equal to digital identity. So the first step is you need to protect your privileged identities. These identities have more than the normal users, right? And if compromised, allows a malicious hacker to access sensitive corporate assets. Helping secure these privileged identities is a critical step to establishing security assurance for business assets in the modern organization. Cybercriminals target these accounts and other privileged services in their kill chain to carry out their objectives. So before we start with privileged identity management, I would like to talk about evolution of identity as well. Identity management approaches have evolved from traditional to advanced to optimal now. So what is a traditional identity approach? Traditional identity approaches on-premises identity providers, no single sign-on to present between on-premises and cloud apps, and the visibility into identity risk is very limited. So how did identities evolve from traditional to advanced? Let's look at advanced identity approaches. In the advanced approach, cloud identity federates with cloud identity systems. Conditional access policies gate access and provide remediation actions. And we can always use analytics to improve visibility into identity risk. And now let's look into the optimal identity approaches. In the optimal model, you always use passwordless authentication and it is always enabled. And user, location, devices, and behavior are analyzed in real time. And continuous protection to identity risk is always enabled. So what are the steps you can take for a passwordless world? The first recommendation I can provide is you need to always think about enforcing multi-factor authentication. You can use fast identity online, which is FIDO 2.0 standard. So you can require a PIN and a biometric for authentication rather than a password. Windows Hello is one good example, but choose the MFA method that works for your organization. Second step towards a passwordless world is to reduce legacy authentication workflows. So you need to figure out how to place apps that require passwords into separate user access portal and migrate user to modern authentication flow most of the time. At Microsoft, only 10% of their users enter a password on a given day. And the third step for a passwordless world is to remove password completely. You can create consistency across Active Directory and Azure Active Directory to enable administrators to remove passwords from Identity Directory. So that's why I'm going to recommend to check out Azure AD Privileged Identity Management as the service to help protect your privileged account. Alright, so now finally we reached at a point so I can explain what is privileged identity management. With the Azure AD Privileged Identity Management Service, you can manage, control, and monitor access to important resources in your organization. This includes access to resources in Azure AD, Azure, and other Microsoft online services like Office 365 and Microsoft Intune. This control does not eliminate the need for users to carry out privileged operation in Azure AD, Azure, Office 365, and other software as a services apps. Organizations can give users just-in-time privileged access to Azure resources and Azure AD. PIM, or Privileged Identity Management, helps mitigate the risk of excessive, unnecessary, or misused access rights. Let's start with just-in-time privileged identity access. Providing just-in-time privileged access to Azure AD and Azure resources, IT administrators can pick on activation period between 0 to 24 hours. They will only receive the privilege for that period of time. After the activation period, admins will have to go through the activation process again. Second key feature is time-bound. Assuming time-bound access to resources by using start and end dates. PIM allows you to set an end time for the role. This is particularly useful in a guest scenario. The third key feature is ability to have approval to activate privileged roles. You can designate one or more approvers. These approvers will receive an email once a request is made. Approval is required to activate the privilege. The fourth key feature is Azure Multi-Factor Authentication or MFA. If your organization already has MFA enabled, PIM will not ask the user to sign in again. Let's look at the fifth feature, which is about justification. Using justification to understand why users activate. This benefits both internal and external auditors understanding why the role was activated. You can also require a service ticket number from whatever service product you are using. Another feature is getting notifications. Getting notification when a user is assigned a privilege and when that privilege is activated. The next one is about access reviews. Conducting access reviews to know which users have privileged role in the organization and if they still need them. And the last one is downloading an audit history for an internal and external audit. This keeps tracks of all PIM events. Let me first show you how you can find privileged identity management and how you can configure the PIM to work for your requirement. I'm on my Azure portal. Go to the global search box and type in privileged identity management. So let me tell you what are the things you can use privileged identity management for. The first one is you can view which users are assigned privileged roles to manage Azure resources, as well as which users are assigned administrative roles in Azure AD. The second way you can use privileged identity management is to activate just-in-time access. So you can activate on-demand just-in-time access, administrative access to Microsoft online services like Office 365 and Intune, and to Azure resources of subscriptions, resource groups, and individual resources such as virtual machines. The next way you can use PIM is to review a history of administrator activation, including what changes administrators made in Azure resources. You can get alerts about changes in administrative assignments as well. You can get alerts about changes in administrator assignments. And by using that, you can enable require access to activate Azure AD privileged admin roles. Then you will be able to review membership of administrative roles and require users to provide a justification for continued membership as well. Now let's understand privileged identity management scope. First, what is Azure AD roles? These roles are all in Azure Active Directory, such as Global Administrator, Exchange Administrator, and Security Administrator. You can read more about these roles and their functionality in Administrative Role Permissions in Azure Active Directory. The next one is Azure Resource Roles. These roles are linked to an Azure resource group, subscription, or management group. PIM provides just-in-time access to both built-in roles like owner, user access administrator, and contributor, as well as custom roles. Now let's understand how can you onboard PIM. First and foremost, to use privileged identity management, you need one of the following paid or trial licenses, which is Azure AD Premium P2 or Enterprise Mobility Plus Security, which is EMS E5, or Microsoft 365 E5. The first global administrator to use the PIM in your instance of Azure AD is automatically assigned to the security administrator and privileged role administrator roles in the directory. This person must be an eligible Azure AD user. Only privileged role administrators can manage the Azure AD directory role assignment of users. No one else in your Azure Active Directory organization gets write access by default. Other global administrators, security admins, security reader have read-only access to privileged identity management. To grant access to the privileged identity management, the first user can assign others to the privileged role administrator. Please make sure there are always at least 2 users in a privileged role administrative role in case one user is logged out or their account is deleted. So let us look at how we can configure the PIM and what are the settings available to configure privileged identity management. First, let's look at the activation settings. Under activation settings, there are few key things. The first one is activation duration. You can set the maximum time in hours that a role always stays before it expires. This value can be from 1 to 24 hours. The second option is require multi-factor authentication on activation. You can require users who are eligible for a role to prove who they are using Azure multi-factor authentication before they can activate. Multi-factor authentication ensures that the user is who they say they are with reasonable certainty. Enforcing this option protects critical resources in situation when the user account might have been compromised. The next option is for the user to require a justification. You can request that user enter a business justification when they activate. And the last option is require approval to activate. If setting multiple approvers, approval completes as soon as one of them approves or denies. You can't require approval from at least two users. Let's look at the next settings, which is all about assignment. Under assignment, there are two important settings. The first one is allow permanent eligible assignment. Global admins and privileged role admins can enter permanent eligible assignment. They can also require that all eligible assignments have a specified start and end date. The second important setting is allow permanent active assignment. These settings allow global admins and privileged role admins will be able to assign active enable assignment. They can also require that all active assignments have a specified start and end date. In some cases, you might want to assign a user to a role for a short duration, probably for 1 day, for example. In this case, the assigned users don't need to request activation. In this scenario, privileged identity management can't enforce multi-factor authentication when the user uses their role assignment because they are already active in the role from the time that it is assigned. And the last settings we need to be aware about is about notification settings. Notification can be sent when members are assigned as eligible in a role, assigned as active in a role, and when the role is activated. And notification can be sent to admins, requesters, and approvers. Now let's have a look at how PIM's elevated workflow look like. By configuring Azure AD PIM to manage our elevated access roles in Azure AD, we now have just-in-time access for more than 28 configurable privileged roles. We can also monitor access, audit account elevations, and receive additional alerts through a management dashboard in Azure Portal. Elevated access include job roles that needed greater access, including support, resource administrators, resource owners, service administrators, and global administrators. We manage role-based access at the resource level. Because elevated access accounts could be misused if they are compromised, we rationalize new requests for elevated access and perform regular re-attestation for elevated roles. This is an example diagram which shows the elevated access workflow. Now let's have a look at how just-in-time administrative access looks like. Azure AD PIM introduced the concept of permanent and eligible administrators in Azure AD and Azure. Permanent administrators have persistent elevated role connections, whereas eligible administrators have privileged access only when they need it. The eligible administrative role is inactive until the employee needs access. Then they complete an activation process and become an active administrator for a set amount of time. Now let's understand role activation in Azure Active Directory. To activate a role, an eligible admin will initialize Azure AD PIM in the Azure portal and request a time-limited role activation. The activation is requested using the Active My Role option in Azure AD PIM. Users requesting activation must satisfy conditional access policies to ensure that they are coming from authorized devices and location, and their identities must be verified through a multi-factor authentication as well. And how can you track the use of privileged identity roles using a dashboard? Azure provides a centralized reporting dashboard where you can go and look at alerts that points out opportunities to improve security. Then you can get a report where you can find the number of users who are assigned to each privileged role, and you would be able to find the number of eligible permanent admins as well. And then there is a report which gives you reports on ongoing access reviews as well. So that concludes the episode 5, which was all about Microsoft Zero Trust model and Azure Privileged Identity Management. In the next video, we're going to learn about hybrid identity and how can you secure hybrid identity. Let's have a high level look at the things what we're going to learn on this video. We will start with what is Azure AD Connect and what are the different types of authentication options available. We will go deep into what is password hash synchronization or PHS or pass-through authentication, which is PTA. Then we will discuss about federation with Azure AD and what are the options available with Azure AD Connect, which include password write back and other options as well. And we will finish off this episode with authentication decision tree. So without wasting any more time, let's get into it. One of the most important tool or components you need to understand for hybrid identity is Azure AD Connect. So what is an Azure AD Connect? Azure AD Connect will integrate your on-premises directories with Azure Active Directory. This allows you to provide a common identity for your users for Office 365, Azure, and SaaS applications integrated with Azure AD. Now let us understand what are the Azure AD Connect features. The first feature which I would like to highlight is called password hash synchronization or PHS. We will go deep into it later, but let me quickly give you a high-level view on what is PHS. Password hash synchronization is a sign-in method that synchronizes a hash of a user's on-premises AD password with Azure AD. The next feature is PTA, which is pass-through authentication. PTA is a sign-in method that allows users to use the same password on-premises and in the cloud, but doesn't require the additional infrastructure of a federated environment. The next feature is federation integration. Federation is an optional part of Azure AD Connect and can be used to configure a hybrid environment. Federation is an optional part of Azure AD Connect and can be used to configure a hybrid environment using an on-premises ADFS infrastructure. It also provides ADFS management capabilities such as a certificate renewal and additional ADFS server deployments. The next feature which I would like to share is all about synchronization. Synchronization is responsible for creating users, groups, and other objects, as well as making sure identity information for your on-premises users and groups is matching the cloud. The synchronization also includes password hashes. And the last feature is about health monitoring. Azure AD Connect Health can provide a robust monitoring and provide a central location in Azure portal to view this activity. Now let's understand what is Azure AD Connect Health. So before that, let me tell you, why do you first of all need a Connect Health tool? When you integrate your on-premises directory with Azure AD, your users are more productive because there is a common identity to access both cloud and on-premises resources. However, this integration creates the challenge of ensuring that this environment is healthy so that users can reliably access resources both on-premises and in the cloud from any device. Azure AD Connect Health provides robust monitoring of your on-premises infrastructure, and it enables you to maintain a reliable connection to Office 365 and Microsoft Online services as well. This reliability is achieved by providing monitoring capabilities for your key identity components. And Azure AD Connect Health helps you monitor and gain insight into synchronizations that occur between your on-premises ADDS and Azure AD as well. Please note that to make Azure AD Connect work, you need to install an agent on each of your on-premises sync servers. Now let's understand authentication options available. Choosing an Azure AD authentication method is one of the most important first decisions you will make. You can choose cloud authentication, which include Azure AD password hash synchronization and Azure AD pass-through authentication. Or you can also choose federated authentication, where Azure AD hands off the authentication process to a separate trusted authentication system. such as an on-premises Active Directory Federation services to validate the user's password. So let me give you a couple of scenarios. The first scenario is, do you need on-premises Active Directory integration? If your answer is no, then you would use cloud-only authentication. Now let us understand what is password hash synchronization or PHS. Password hash synchronization is a feature used to synchronize users' password from an on-premises Active Directory instance to a cloud-based Azure AD instance. Use this feature to sign into Azure AD services like Office 365, Microsoft Intune, CRM Online, and Azure Active Directory domain services. You sign into these services by using the same password you use to sign into your on-premises Active Directory instance as well. Password hash synchronization help you to improve the productivity of your users and reduce your help desk cost. So how does this work? In the background, the password synchronization components take the user's password hash from on-premises Active Directory, encrypts it, and passes it as a string to Azure. Azure decrypts the encrypted hash and store the password hash as a user attribute in Azure AD. When the user sign into the Azure service, the sign-in challenge dialog box generates a hash of the user's password and passes that hash back to Azure. Azure then compares the hash with one in that user account. If the two hashes match, then the two passwords must also match, and then the user receives access to the resource. It is important to understand that this is a same sign-in, not a single sign-on. This solution provides a simple alternative to ADFS integration. Now let's understand what is pass-through authentication or PTA. Azure AD pass-through authentication is an alternative to Azure AD password hash synchronization and provides the same benefit of cloud authentication to organizations. PTA allows users to sign in to both on-premises and cloud-based applications using the same user account and passwords. When users sign in using Azure AD, pass-through authentication validates the user's passwords directly against an organization's on-premises Active Directory. So what are some of the features and benefits of pass-through authentication? PTA supports user sign-in into all web browser-based applications and into Microsoft Office client applications that use modern authentication. This allows users to work seamlessly with conditional access features such as multi-factor authentication to help secure your users. And PTA is a free feature and you don't need any paid edition of Azure AD to use it. And PTA can be enabled via Azure AD Connect. PTA uses lightweight on-premises agent that listens for and responds to password validation requests. Installing multiple PTA agents provides high availability of sign-in requests, and PTA protects your on-premises accounts attack against brute force password attacks in the cloud. Now let's understand the federation with Azure AD. Federation is a collection of domains that have established trust. The level of trust may vary, but typically includes authentication and almost always includes authorization. A typical federation might include a number of organizations that have established trust or shared access to a set of resources. You can federate your on-premises environment with Azure AD and use this federation for authentication and authorization. This sign-in method ensures that all user authentication occurs on-premises. This method allows administrators to implement more rigorous level of access control. Please note that if you decide to use federation with Active Directory Federation Services, or it is known as ADFS, you can optionally set up password hash synchronization as backup in case your ADFS infrastructure fails. Now let's understand what is password write back. Password write back is a feature enabled with Azure AD Connect that allows password changes in the cloud to be written back to an existing on-premises directory in real time. So what are the options and features and benefits of password write back? So let's have a look at the options and the features and the benefits of password write back. First of all, Password write back allows enforcement of on-premises Active Directory password policies. When a user resets their password, it is checked to ensure it meets your on-premises Active Directory policy before committing it to that directory. This review includes checking the history, complexity, age, password filters, and any other password restrictions that you have defined in your local Active Directory. The second option what Password Writeback provide is zero-day feedback. Password Writeback is a synchronization option. Your users are notified immediately if their password did not meet the policy or could not be reset or changed for any reason. Another ability is Password Writeback support password changes from the Access panel and Office 365. When federated or password hash synchronization users come to change their expired or non expired password, these passwords are written back to your local Active Directory environment. The next option which it's provide is password write back support when an admin resets from the Azure portal. When an admin resets a user password in the Azure portal, if that user is federated or password has synchronized, the password is written back to on-premises. This functionality is currently not supported in the Office admin portal. And finally, password write back doesn't require any inbound firewall rules, which means password write back uses an Azure Service Bus relay as an underlying communication channel. All communication is outbound over port 443. Please note that to use self-service password reset, you must have already configured Azure AD Connect in your environment. Alright, so now let's understand Azure AD external identities. There are a number of flavors of Azure Active Directory that allows you to work with external identities, that is, users that are outside of your organization. The first one is Azure AD itself, sometimes known as Azure AD B2E, which is business to enterprise. When writing application for Azure AD, you can target users from a single organization, which is a single tenant, or users from an organization that already has an Azure AD tenant, which is called multi-tenant application. The second flavor is called Azure AD B2B or business to business. This isn't so much a different directory service. It's an extension on top of Azure AD that allows you to work with external identities, mainly for collaboration scenarios using Microsoft applications. For example, Office 365, Microsoft Teams, and Power BI. In Azure AD B2B, you invite external users into your own tenant as guest users that you can then assign permission to for authorization while still allowing them to keep using their existing credentials for authentication inside their organization. And the third flavor is Azure AD B2C. It is known as either business to consumer or customer or even citizen. This is a separate directory service but still built on top of the global Azure AD infrastructure, which enable you to customize and control how customers sign in, which enables you to customize and control how customers sign up, sign in, and manage their profiles when using your applications. To choose the appropriate Azure AD flavors for your project, there are a number of decisions factors that come into play. I will help you understand what are some of the questions you can think of, and you can use this decision tree to come to a conclusion which one is the right approach. The first question you should ask yourself is, should any user from any and all existing Azure AD tenant be available to sign in? Or do you prefer to view the users in your own Azure AD tenant as guest? Or do you need extensive support for branding and customization? Or other question you could ask is creating just-in-time unmanaged Azure AD tenant acceptable? So this decision tree is intended as a starting point to understand your options, but there can be others or even combination of different options as well. Alright, so that concludes our episode on hybrid identity, and that finishes our first module as well. In the next video, we're going to have a quick knowledge check to validate our knowledge on what we have learned on the previous videos. Let's look at the first question. Your organization is considering Azure multi-factor authentication and your manager asks about secondary verification methods. Which of the following is not a valid option? You just need to select one answer. Is it text message with automated code? That is a valid option. Even the push notification to your phone is a valid option. You can use Azure Authentication app with OAuth verification code as well. Even the automated phone call is a valid option. So the one which is not a valid option and the correct answer for this question is emailed link to verification website. This is not a validation method used by Azure multi-factor authentication. Let's look at question number 2. Your organization has implemented Azure multi-factor authentication and you need to provide a status report by user account. Which of the following is not a valid multi-factor authentication status? You need to select one. So disabled, enabled, and enforced are all our valid option. So the one which is not a valid option is required. MFA has three user states: enabled, enforced, and disabled. Let's look at question number 3. You are configuring Azure multi-factor authentication. You can configure all the following options except one. Which one is that? We need to select one answer. So the correct answer is configure IP addresses outside the company internet that should be blocked. Trusted IP is a feature of allowed federated users or IP address range to bypass two-step authentication. The trusted IP's bypass works only from inside of the company intranet. Azure Conditional Access provide additional options if needed. Let's look at question number 4. You are assigning Azure AD roles. Which role will allow the user to manage all the groups in a tenant and would be able to assign other admin roles as well? You just need to select one answer. So it is definitely not user administrator or security administrator or password administrator. The correct answer is global administrator. Only the global administrator can manage group across tenant and assign other administrator roles. Let's look at question number 5. You are creating an Azure AD security group. All the following are the ways you can assign group membership except one. Which one is that? You can assign a group membership by using assigned, dynamic device, and dynamic user, but you won't be able to assign using Office 365 user. When you create an Azure AD group, you can select assigned, dynamic device, or dynamic user. Assigned let you add members directly to the group, and dynamic device uses rules to automatically add and remove devices. Let's look at question number 6. Your compliance auditors want to ensure as employees change jobs or leave the company that their privileges are also changed or revoked. They are especially concerned about the administrator group. To address their concerns, you implement which of the following? It is definitely not management group or just-in-time access or Azure time-based policies. The correct answer is access reviews. Access reviews enable organizations to effectively manage group membership, access to enterprise applications, and role assignments. Users' access can be reviewed on a regular basis to make sure only the right people have continued access. Let's look at question number 7. Identity Protection has reported that a user's credentials has been leaked. According to policy, the user's password must be reset. Which Azure AD role can reset the password? You just need to select one. So the correct answer is Global Administrator. To use Identity Protection, a user must be on one of these roles. Each role has different privileges, but only Global Administrator can reset a user's password. Let's look at question number 8. Identity Protection identifies risk in following classification except what? You just need to select one answer. So the correct answer is unregistered device. Valid identity protection risk include all choices except unregistered device. Other risk classifications are malware linked IP address, leaked credentials, and Azure AD threat intelligence. Let's look at the next question. You have implemented identity protection and are reviewing the risky users report. For each reported event, you can choose any of the following actions except what? You can use block user from signing in and you can confirm user compromises as well. Along with you can dismiss user risk. The only option which doesn't fit here is delete the risk event. When reviewing risk events, you should evaluate each risk and then take action to block the user, confirm the compromise, dismiss the risk, reset the user password, or investigate further using Azure Advanced Threat Protection. Let's look at question number 10. Conditional access policies can help with all the following except which one? Conditional access can help you with block or grant access from specific location. It can be used to require multi-factor authentication and require to use trusted location as well. The one which doesn't fit in here is designate privileged user accounts. Conditional access policies at their simplest are if-then statements. If a user wants to access a resource, then they must complete an action. Let's look at question number 11. Which licensing plans support identity protection? So the correct answer is Azure Active Directory P2. Identity protection helps you configure risk-based conditional access for your application to protect them from identity-based risks. Okay, let's look at question number 12. You hire a new administrator and you create a new Azure AD user account for them. The new hire must be able to read-write resource deployment they are responsible for, and they must be able to read Azure AD access permissions as well. They should not be able to view Azure subscription information. So what should you do? You just need to select one answer. So the correct answer is assign the user the contributor role at the resource group level. This will give the new hire the least privileges necessary for the role. Let's look at question number 13. Which of the following would be a good example of when to use resource lock? The correct answer is an express route circuit with connectivity back to your on-premises network. Resource locks prevent other users in your organization from accidentally deleting or modifying critical resources. And express route is a critical resource. You have three virtual machines, VM1, VM2, and VM3 in a resource group. The help desk hires a new employee, and the new employee must be able to modify the settings on VM3, but not on VM1 and VM2. Your solution must minimize administrative overhead. What should you do? You just need to select one answer. The correct answer is assign the user to the contributor role on VM3. This means the user will not have the access to VM1 and VM2. By assigning the contributor role to the current resource group is incorrect, as it would allow the new hire to change the settings on VM1 and VM2 and therefore would meet the requirements. Let's look at question number 15. You need to target policies and review spend budget across several subscriptions you manage. What should you create for the subscriptions? The correct answer is management group. Management groups can be used to organize and manage subscriptions. Let's look at question number 16. Your manager asks you to explain how Azure user resource groups. You can provide all the following information except what? You basically can read out the statement and figure out which one is not correct. So the correct answer is resource group can be nested. Even though it's the correct answer for this, it's actually a wrong statement. All other options are the features of resource group. Let's look at question number 17. You wish to enable Azure AD PIM for your directory. What Azure AD role do you need to enable privileged identity management? Select one. So the correct answer is global admin or global administrator. Global admin role has the permission to enable privileged identity management. Your company has implemented Azure AD PIM. You need to ensure a new hires request elevation before they make any changes in Azure. What should you do? You just need to select one. The correct answer is assign the new hire the eligible role membership type. When someone is eligible for role membership, they must request activation before they can use the role. Azure AD PIM is used to manage which two of the following? The correct answers are Azure AD roles and Azure AD resource roles. Let's look at question number 20. Your organization has enabled Azure AD PIM. The senior IT manager does not want to perform any action to use a role. What should you do? Select one. The correct answer is make the manager permanent active in the role. This type of role assignment doesn't require a user to perform any action to use the role. Let's look at question number 21. Your IT help desk want to reduce password reset support tickets. You suggest having users sign in to both on-premises and cloud-based application using the same password. Your organization does not plan on using Azure AD identity protection. So which feature would be easiest to implement given the requirement? So the correct answer is pass-through authentication. Pass-through authentication or PTA allows your users to sign into both on-premises and cloud-based application by using same passwords. Let's look at question number 22. Which tool can you use to synchronize Azure AD password with on-premises Active Directory? The correct answer is Azure AD Connect. Azure AD Connect sync is a main component of Azure AD Connect. It takes care of all the operations that are related to synchronize identity data between your on-premises environment and Azure AD. Let's look at question number 23. Azure AD does not use which of the following security protocols? The one protocol in the list which is not used by Azure AD is Kerberos, because Azure AD is HTTP or HTTPS based. It does not use Kerberos authentication. Instead, it uses HTTP and HTTPS protocol such as SAML, WS Federation, and OpenID Connect for authentication and OAuth for authorization. Let's look at the last question. Which of the following is not a passwordless authentication option that integrates with Azure Active Directory? You just need to select one answer. The correct answer is multi-factor authentication. MFA is a great way to secure your organization, but users often get frustrated with additional security layer on top of having to remember their passwords. All right, so that concludes module 1. And in the next video, we are starting a brand new module, which is module 2. And the first lesson we are going to learn is all about perimeter security. Let's have a high level look at what are the things we are going to learn in this video. We will start with understanding what do you mean by defense in depth, and how about virtual network security? How can you implement DDoS, and what is DDoS all about? We will touch base on Azure Firewall and the features of Azure Firewall and how can you implement Azure Firewall. Then we will finish off this lesson talking about VPN force tunneling and UDR and NVAs. If you're wondering what is UDR, it's user-defined routes and network virtual appliances. So without wasting any more time, let's get into it. So what is a defense in depth approach? The defense in depth approach includes additional controls in the design to mitigate risk to the organization in the event a primary security control fails. This design should consider how likely the primary control is to fail, the potential organizational risk if it does, and the effectiveness of the additional control. During this video, we will explore the defense in depth design of Azure services and capabilities to help you securely manage and monitor your cloud data and infrastructure as a managed service. Microsoft designs and operates its cloud services with security at the core and provide you built-in control and tools to meet your security needs. In addition, with machine learning and Microsoft's significant investment in cyber defense, you can benefit from unique intelligence and proactive measures to protect you from threats. Azure offers unified security management and advanced threat protection for your resources, whether they are in the cloud, your data center, or both. Services in Azure are built with security in mind from ground up to host your infrastructure, apps, and data. All services are designed and operated to support multiple layers of defense, spanning your data apps, virtual machines, network perimeter related policies, and of course, physical security within Microsoft data centers. This strategy is illustrated in this example image. As more and more of a company's digital resources reside outside of the corporate network, in the cloud, and on personal devices, it becomes obvious that a perimeter only based security, that is, firewalls, DMCs, VNets, are no longer adequate. The adoption of software defined network and software defined data center technologies are driving network segmentation concept to be more granular. So let's understand what is this concept of network microsegmentation. Microsegmentation is a way to create secure zones in data centers and Azure deployment that allows you to isolate workloads and protect them individually. Security policies in a virtual environment can be assigned to virtual connections that can move with an application if the network is reconfigured. So, by making the security policies persistent, a best practice recommendation is to adopt a zero trust strategy based on user, device, and application identities. So let us have a look at some of the Microsoft microsegmentation strategies. First of all, it's Azure Network Security Groups. Azure Network Security Groups can be used for basic layer 3 and 4 access controls between Azure virtual networks, their subnets, and the internet. Another type of microsegmentation you can do is application security groups. ASDs enable you to define fine grained network security policies based on workloads centralized on applications instead of explicit IP addresses. The third type of microsegmentation is Azure Web Application Firewall and the Azure Firewall. These can be used for more advanced network access controls that require application layer support. And the fourth type of microsegmentation is about local admin password solution or LAPS. LAPS or third party privileged access management can set strong local admin passwords and just in time access for them. Additionally, third parties offer microsegmentation approaches that may enhance your network controls by applying zero trust principles to networks you control. Let's understand about Azure Virtual Network Security. Azure Virtual Networks are a key component of Azure Security Services. The Azure Network Infrastructure enable you to securely connect Azure resources to each other with virtual networks. It is known as VNets. A VNet is a representation of your own network in the cloud. A VNet is a logical isolation of the Azure Cloud Network dedicated to your subscription. You can connect VNet to your on-premises networks as well. Azure supports dedicated WAN link connectivity to your on-premises network and Azure Virtual Network with ExpressRoute. The link between Azure and your site uses a dedicated connection that does not go over the public internet. If your Azure application is running in multiple data centers, you can use Azure Traffic Manager to route requests from users intelligently across instances of the application. You can also route traffic to services not running in Azure if they are accessible from the internet. Let's talk about Azure Virtual Network. Azure Virtual Network enables many types of Azure resources, such as Azure VMs, to securely communicate with each other, the internet, and on premises networks. A virtual network is scoped to a single Azure region. An Azure region is a set of data centers deployed within a latency defined perimeter and connected through a dedicated regional low latency network. Virtual networks are made up of subnets, and a subnet is a range of IP addresses within your virtual network. You can implement multiple virtual networks within each Azure subscription and Azure region. Each virtual network is isolated from other virtual networks. Now that we have learned about virtual network, let's talk about Azure IP addresses. VMs, Azure load balancers, and application gateways in a single virtual network require unique IP addresses, the same way that clients in an on-premises subnet do. This enables these resources to communicate with each other. A virtual network uses two types of IP addresses: private and public. So, what is a private IP address? A private IP address is dynamically or statically allocated to a VM from a defined scope of IP address in the virtual network. VMs use these addresses to communicate with other VMs in the same or connected virtual network through a gateway or Azure ExpressRoute connection. Then what is a public IP address? Public IP addresses are the one which is allowing Azure resources to communicate with external clients, and they are assigned directly to the virtual network adapter of the VM or the load balancer. Public IP addresses can also be added to an Azure only virtual networks. All IP blocks in a virtual network will be routable only within this customer network, and they won't be reachable from outside. Let's understand what is distributed denial of service or DDoS. A denial of service attack is an attack that has the goal of preventing access to services or systems. If the attack originates from one location, it is called DOS. If the attack originates from multiple networks and systems, it's called distributed denial of service or DDoS. Before learning about what is DDoS, we need to understand what are botnets. Botnets are collections of internet connected systems that an individual controls and uses without their owner's knowledge. Botnet owners use them to perform various actions of their choosing. Often, they use them for spamming, data storage, DDoS, or various other actions that are up to the person in control of the botnet. So, DDoS is a collection of attacks types aimed at disrupting the availability of a target. These attacks involve a coordinated effort that uses multiple internet connected systems to launch many network requests against DNS, web services, email, and more. Pretty much any application that the malicious hacker can access might become the target of a DDoS. A DDoS generally involves many systems sending traffic to target as part of a botnet. In most cases, the owners of the system in the botnet don't know that their devices are compromised and participating in an attack. Botnets are becoming a bigger problem than before because the increasing number of connected devices. So, designing and building the DDoS resiliency requires planning and designing of a variety of failure modes. Now that we have understood about DDoS and how hackers use these botnets to perform these DDoS attacks, let's go ahead and understand how can you implement DDoS. Azure DDoS protection combined with application design best practices provide defense against DDoS attacks. Azure DDoS protection provides two service tiers, basic and standard. So let's understand what is a basic DDoS tier. Basic DDoS is automatically enabled as part of the Azure platform. Always on traffic monitoring and real-time mitigation of common network level attacks provide the same defenses utilized by Microsoft Online Services. The entire scale of Azure Global Network can be used to distribute and mitigate attack traffic across regions. Protection is provided for IPv4 and IPv6 public IP addresses. So then what is a standard DDoS protection? A standard tier provides additional mitigation capabilities over the basic service tier. DDoS protection for standard is simple to enable and require no application changes. Protection policies are tuned through dedicated traffic monitoring and machine learning algorithms. Policies are applied to public IP addresses associated to resources deployed in virtual network such as Azure Load Balancer, Azure Application Gateway, and Application Service Fabric instances. But this protection does not apply to app services environment. Real-time telemetry is available through Azure Monitor. So how does the DDoS protection works? DDoS protection standard monitors actual traffic utilization and constantly compare it against the threshold defined in the DDoS policy. When the traffic threshold is exceeded, DDoS mitigation is automatically initiated. When traffic returns to the level below the threshold, the mitigation is removed. DDoS protection standard can mitigate three types of attacks: volumetric attacks, protocol attacks, and resource layer attacks. So let us understand what is a volumetric attacks. This attack's goal is to flood the network layer with a substantial amount of seemingly legitimate traffic. It includes UDP floods, amplification floods, and other spoof packet floods. DDoS protection standard mitigates these potential multi-gigabyte attacks by absorbing and scrubbing them with Azure Global Network Scale automatically. The next type of attack which standard DDoS protection can mitigate is protocol attacks. So, what is a protocol attack? These attacks render a target inaccessible by exploiting a weakness in the Layer 3 and Layer 4 protocol stack. It includes SYN flood attacks, reflection attacks, and other protocol attacks. And the third type of attack is resource or application layer attacks. These attacks target web application packets to disrupt the transmission of data between hosts. The attack include HTTP protocol violations, SQL injection, and cross-site scripting and other layer 7 attacks. So DDoS protection standard protects the resources in a virtual network, including public IP address associated with the virtual machines, load balancers, and application gateways. When coupled with the application gateway, web application firewall, or third-party web application firewall deployed in a virtual network with public IP, DDoS protection standard can provide full layer 3 and layer 7 mitigation capability. Now let's understand what is Azure Firewall. Azure Firewall is a managed cloud-based network security service that protects your Azure virtual network resources. It's a fully stateful firewall as a service with built-in high availability and unrestricted cloud scalability. By default, Azure Firewall blocks traffic. Azure Firewall comes with great built-in features as well. Let's go through these features one by one. The first one is built-in high availability. Because high availability is built into Azure Firewall, no additional load balancers are required and there is nothing you need to configure. The second feature is unrestricted cloud scalability. Azure Firewall can scale up as much as you need to accommodate changing network traffic flows, so you don't need to budget for your peak traffic. The third feature is application FQDN filtering rules. You can limit outbound HTTP or HTTPS traffic to a specified list of FQDNs, including wildcards. This feature does not require SSL termination. The fourth type is network traffic filtering rules. You can centrally create, allow, or deny network filtering rules by source and destination IP addresses, port, and protocol. Azure Firewall is fully stateful, so it can distinguish legitimate packets from different types of connections. Rules are enforced and logged across multiple subscription and virtual networks. Another feature is FQDN tags. Fully qualified domain names tags make it easier for you to allow well-known Azure Service Network traffic through your firewall. For example, say you want to allow Windows Update network traffic through your firewall, you create an application rule and include the Windows Update tag. Now network traffic from Windows Update can flow through your firewall. Another feature is outbound source network address translation or OSNAT support. All outbound virtual network traffic IP addresses are translated to Azure Firewall public IP. You can identify and allow traffic originating from your virtual network to remote internet destinations. Next feature is inbound destination network address translation or DNAT support. Inbound network traffic to your firewall public IP address is translated and filtered to the public IP address on your virtual networks. And the last feature which I would like to highlight is about Azure Monitor logging. All events are integrated with Azure Monitor, allowing you to archive logs to a storage account, stream events to your Event Hub, or send them to Azure Monitor logs. So how can you implement Azure Firewall? Controlling outbound network access is an important part of an overall network security plan. For example, you want to limit access to websites, or you may want to limit the outbound IP addresses and ports that can be accessed. One way you can control outbound network traffic from the Azure subnet is with Azure Firewall. With Azure Firewall, you can configure application rules that define fully qualified domain names that can be accessed from a subnet, or you can configure network rules that define source addresses, protocols, destination port, and destination addresses. So let's understand some of the Azure firewall concepts. First, let's look at what is FQDN tags. An FQDN tag represents a group of fully qualified domain names associated with well-known Microsoft services. You can use an FQDN tag in application rule to allow the required outbound network traffic through your firewall. The next one is infrastructure FQDNs. Azure firewalls include built-in rule collection for infrastructure FQDNs that are allowed by default. These FQDNs are specific for the platform and can't be used for any other purposes. Some of the services which is included in the built-in rule are compute access for storage platform image repository, managed status storage access, and Azure diagnostics and logging. Now let's understand logs and metrics. You can monitor Azure Firewall using firewall logs. You can also use activity logs to audit operations on Azure Firewall resources. And logs can be sent to Azure Monitor Logs, storage, and event hubs in Azure Monitor. Or it can be used to send to different tools such as Excel and Power BI, etc. The next concept is threat intelligence-based filtering. Threat intelligence-based filtering can be enabled for your firewall to alert or deny traffic to and from known malicious IP addresses and domains. Another concept is rule processing logic. You can configure NAT rules, network rules, and application rules on Azure firewalls. And rule collections are processed according to the rule type in the priority order, lower number to higher number from 100 to 65,000. Next concept is service tags. A service tag represents a group of IP address prefixes to help minimize complexity of security rule creation. You cannot create your own service tag nor specify which IP addresses are included within a tag. Azure Firewall Service Tag can be used in the network rule destination field, and you can use them in place of specific IP addresses. You can use Azure Firewall to support the remote work as well, which includes VDI and virtual desktop support as well. Now let's have a look at what is VPN force tunneling and why do some cases require force tunneling. Force tunneling lets you redirect or force all internet-bound traffic back to your on-premises location via site-to-site VPN tunnel for inspection and auditing. This is a critical security requirement for most enterprise IT policies. Without force tunneling, internet-based traffic from your VMs in Azure always traverses from the Azure Virtual Network infrastructure directly to the internet, without the option to allow you to inspect or audit the traffic. This is an example diagram which shows how force tunneling works. You configure force tunneling in Azure via virtual network user-defined routes. Redirecting traffic to the on-premises site is expressed as a default route to the Azure VPN gateway. So in this example, it uses UDR to create a routing table to first add a default route and then associate the routing table with your virtual network subnets to enable force tunneling on those subnets. Alright, so that concludes this lesson. We learned about Azure Perimeter Security. In the next episode, we're going to talk about network security. Let's have a high-level look at the things what we're going to learn in this video. We will start with understanding what is network security groups or NSG, and you will learn how to implement NSGs as well. Along with that, you will learn about what is ASG, which is application security groups. Then we will cover the concepts like service endpoints, private links, etc. Then we will learn about Azure Application Gateway and Web Application Firewall and services like Azure Front Door and Express Route as well. So without wasting any more time, let's get into it. So what is NSGs? Network traffic can be filtered to and from Azure resources in Azure Virtual Network with a network security group. A network security group contains security rules that allow or deny inbound network traffic to or outbound network traffic from several types of Azure resources. For each rule, you can specify source and destination port and protocol. NSGs contain rules that specify whether traffic will be approved or denied. Each rule is based on a source IP address, a source port, a destination IP address, and a destination port. Based on whether the traffic matches this combination, the rule either allows or denies the traffic. Each rule consists of the following properties. The first one is name. This is a unique identifier for the rule. Then we have direction. This specifies whether the traffic is inbound or outbound. Next, we have priority. If multiple rules match the traffic, rules with the higher priority apply. Then we have access. This specifies whether the traffic is allowed or denied. Then source IP address prefix. This prefix identifies where the traffic originated from. It can be based on a single IP address or a range of IP addresses as well. Then we have source port range. This specifies source port by using either a single port number from 1 through 65,535 and a range of ports, for example 200 or 400. Then we have the destination IP address prefix. This identifies the traffic destination based on a single IP address, a range of IP address in CIDR notation, or asterisk to match all possible IP addresses. The next one is destination port range. This specifies destination port by using a single port number from 1 through 65,535. The last one is protocol. This specifies a protocol that matches the rule. It can be a UDP, TCP, or it can be an asterisk as well. When implementing NSGs, we need to keep some important limits in our mind. By default, you can create 100 NSGs per region per subscription, and you can raise the limit to 400 by contacting the Azure support team. You can apply only one NSG to a VM, subnet, or network adapter. By default, you can have up to 200 rules in a single NSG, and you can raise this limit by 500 by contacting Azure support, and you can apply an NSG to multiple resources as well. So how is the traffic is evaluated in NSG? Several resources from Azure services can be deployed into an Azure virtual machine, and you can associate 0 or 1 network security group to each virtual network subnet and network interface in a virtual machine. The same network security group can be associated to as many subnets and network interface as you choose. So let's look at some of the general guidelines. Unless you have a specific reason, Microsoft recommend that you associate a network security group to a subnet or a network interface, but not both. So what is application security groups or ASGs? Application security group enable you to configure network security as a natural extension of an application structure. You then can group VMs and define network security policies based on those groups. You also can reuse your security policy at scale without manual maintenance of explicit IP addresses. The platform manages the complexity of explicit IP addresses and multiple rule sets, allowing you to focus on your business logic. You can specify one ASG as the source and destination in a security rule. You cannot specify multiple ASGs in the source or destination. Now let's look at what is service endpoints. A virtual network service endpoint provides the identity of your virtual network to the Azure service. Once service endpoints are enabled in your virtual network, you can secure Azure service resources to your virtual network by adding a virtual network rule to the resources. A common use case of service endpoint is a virtual machine accessing storage. The storage account restricts access to the virtual machine private IP addresses. So why use a service endpoint? The first reason is it will give you improved security for your Azure service resources. VNet private address space can be overlapping and so cannot be used to uniquely identify traffic originating from the VNet. Service endpoints provide the ability to secure Azure service resources to your virtual network by extending VNet identity to the service. Second reason to use service endpoint is it gives you optimal routing to Azure service traffic from your virtual network. So today, any routes in your virtual network that force internet traffic to your premises or virtual appliances known as force tunneling. Also force Azure service traffic to take the same route as the internet traffic. Service endpoints provide optimal routing to Azure traffic. Another reason is endpoints always take service traffic directly from your virtual network to the service on Microsoft Azure backbone network. So keeping traffic on the Azure backbone network allows you to continue auditing and monitoring outbound internet traffic from your virtual networks through force tunneling without impacting service traffic. Another reason is simple to set up with less management overhead. You no longer need reserved public IP addresses in your virtual network to secure Azure resources through IP firewall. There are no NAT or gateway devices required to set up the service endpoints. Service endpoints would provide so many benefits. So let's look at some of these scenarios. The first one is peered connected or multiple virtual network. To secure Azure services to multiple subnets within a virtual network or across multiple virtual networks, you can enable service endpoints on each of these subnets independently and secure Azure service resources to all of the subnets. Second scenario is filtering outbound traffic from a virtual network to Azure services. If you want to inspect or filter the traffic sent to an Azure service from a virtual network, you can deploy a network virtual appliance within the virtual network. You can then apply service endpoints to the subnet where the network virtual appliance is deployed as well. And this allows you to secure Azure service resources only to this subnet. Another scenario is securing Azure resources to services deployed directly into virtual networks. You can directly deploy various Azure services into specific subnet in a virtual network. The last scenario is disk traffic from an Azure virtual machine. Virtual machine disk traffic for managed and unmanaged disk isn't affected by service endpoints routing changes for Azure storage. This traffic includes disk I/O as well as mount and unmount. Let's understand what are private links. Azure Private Link works on an approval call flow model wherein the private link service consumer can request a connection to the service provider for consuming the service. The service provider can then decide whether to allow the consumer to connect or not. Azure Private Link enables the service providers to manage the private endpoint connection on their resources. There are two connection approval methods that a private link service consumer can select. The first one is automatic. If the service consumer has RBAC permissions on the service provider resource, the consumer can choose the automatic approval method. In this case, when the request reaches the service provider resource, no action is required from the service provider and the connection is automatically approved. And the second connection approval method is manual. On the contrary, if the service consumer doesn't have RBAC permission on the service provider resource, the consumer can choose the manual approval method. In this case, the connection request appears on the service resources as pending. The service provider has to manually approve the request before the connections can be established. Let's understand what is Azure Application Gateway. Azure Application Gateway is a web traffic load balancer that enables you to manage traffic to your web applications. Traditional load balancers operate at the transport layer and route traffic based on source IP address and port to a destination IP address and port. Azure Load Balancer works that way. Application Gateway can make routing decisions based on additional attributes of an HTTP request. Some of the features included in the Azure Application Gateway are Secure Socket Layer or SSL TLS termination, auto scaling, zone redundancy, static VIP, web application firewall, which we will learn in the next slide, ingress controller for AKS, URL based routing, multiple site hosting, redirection, session affinity, and WebSocket and HTTP/2 traffic. New application gateway version 1's queue deployment can take up to 20 minutes to provision. Changes to instance size or count aren't disruptive, and the gateway remains active during this time. Most deployment that uses the version 2's queue take around 6 minutes to provision. However, it can take longer depending on the type of the deployment. For example, deployments across multiple availability zones with many instances can take more than 6 minutes. Now let's learn about what is Web Application Firewall. Web Application Firewall or WAF provides centralized protection of your web applications from common exploits and vulnerabilities. Web applications are increasingly targeted by malicious attack that exploits common known vulnerabilities. SQL injection and cross-site scripting are among the most common attacks. Preventing such attacks in application code is challenging. It can require rigorous maintenance and patching at multiple layers of application topology. A centralized web application firewall helps make security management much simpler. A WAF also gives application administrators better assurance of protection against threat and intrusions. A WAF solution can react to a security threat faster by centrally patching a known vulnerability instead of securing each individual web application one by one. So, what is Azure Front Door? Azure Front Door enables you to define, manage, and monitor the global routing for your web traffic by optimizing for best performance and instant global failover for high availability. With Front Door, you can transform your global, multi region consumer and enterprise applications into robust, high performance, personalized modern applications and content that reaches a global audience with Azure or HTTP HTTPS layer and uses split TCP based Anycast protocol. Front Door ensures that your end users promptly connect to the nearest front door POP. POP means point of presence. Now let's look at some of the features of Azure Front Door. The first one is accelerate application performance. Using split TCP based Anycast protocol, Front Door ensures that your end users promptly connect to the nearest front door POP. Second feature is increase application availability with smart health probes. So Front Door delivers high availability for your critical applications using its smart health probes, monitoring your backends for both latency and availability, and providing instant automatic failover when a backend goes down. Another feature is URL based routing. URL path based routing allows you to route traffic to a backend pool based on URL paths of the request. The next one is multi site hosting. Multiple site hosting enables you to configure more than one website on the same front door configuration. Another one is session affinity. The cookie based session affinity feature is useful when you want to keep a user session on the same application backend. The next one is TLS termination. The front door supports TLS termination at the edge. That is, individual users can set up a TLS connection with front door environment instead of establishing it over long haul connection with application backend. Another feature is custom domain and certificate management. Then you have an ability to add application layer security, URL redirection, and URL rewrite. And finally, you can use it for protocol support, which includes both IPv6 and HTTP2 traffic. So, what are user defined routes? A user-defined routes or UDR is a custom route in Azure that overrides Azure default system routes or adds route to a subnet's route table. In Azure, you create a route table and then associate that route table with zero or more virtual network subnet. Each subnet can have zero or one route table associated with it. If you create a route table and associated it to a subnet, Azure either combines its routes with the default routes that Azure adds to the subnet or overrides those default routes. So, what is network virtual appliances? You can deploy a network virtual appliance to a perimeter network in many architectures. The network virtual appliance help provides a secure network boundary by checking all inbound and outbound network traffic and then passing only the traffic that meets the network security rules. However, the fact that all network traffic passes through the network virtual appliance means that the network virtual appliance is a single point of failure in the network. If the network virtual appliance fails, no other path will exist for network traffic, and all the backend subnets will become unavailable. To make an NVA highly available, deploy more than one network virtual appliance into an availability set. So, what is ExpressRoute? ExpressRoute is a direct private connection from your WAN to Microsoft services, including Azure. Site to site VPN traffic travels encrypted over public internet. Being able to configure site to site VPN and ExpressRoute connection for the same virtual network has several advantages. You can configure a site to site VPN as a secure failover path for ExpressRoute or use site to site VPN to connect to sites that are not part of your network but that are connected through ExpressRoute. Azure Virtual WAN uses Internet Protocol Security or IPsec or Internet Key Exchange, which is IKE VPN connection from your on-premises network to Azure over the private peering of Azure network of an Azure Express Route circuit. This technique can provide an encrypted transit between the on-premises network and Azure Virtual Network over Express Route without going over the public internet or using the public IP address. And finally, what is ExpressRoute Direct? ExpressRoute Direct gives you ability to connect directly into Microsoft Global Network at peering location strategically distributed across the world. ExpressRoute Direct provides dual 100 Gbps or 10 Gbps connectivity, which supports active-active connectivity at scale. So, what are the features of ExpressRoute Direct? ExpressRoute Direct gives you massive data injection into services like storage and Cosmos DB. Another feature is gives you ability of physical isolation for industries that are regulated and require dedicated and isolated connectivity like banking, government, and retail. And this provides granular control of circuit distribution based on business unit as well. All right, so that concludes this episode. In the next video, we're starting a new episode which is all around host security. Let's have a high level look at the things what we are going to learn in this video. We will start with understanding what is endpoint protection and what is PAW, which is privileged access workstations, and what are virtual machine templates and how can you apply these templates, and what are the benefits of using these templates, and how can you remote access management both Windows and Linux machines. How can you use Azure Update Management to update all your virtual machines in Azure? We will talk about how can you protect your disk with disk encryption and how can you turn on Windows Defender to protect your virtual machine instances. And then we will finish off with Security Center host recommendation and some tips on how to secure your Azure workloads. So without wasting any more time, let's get into it. So what is endpoint protection? Computer systems that interact directly with users are considered endpoint systems. Systems on devices such as laptops, smartphones, tablets, and computers all need to be secure to help prevent them from acting as gateways for security attacks on organizations' network systems. In episode 2, we discussed about shared responsibilities of helping secure services in Azure. IaaS involves more customer responsibility than PaaS and SaaS did. And Azure Security Center provides the tools you need to harden your network, help secure your services, and stay on top of your security posture. The first step is to help protect against malware. So, how can you do that? You need to install anti malware to help identify and remove viruses, spyware, and other malicious software from your virtual machine instance. You can install Microsoft anti-malware or endpoint protection solution from a Microsoft partner as well. Second step is to monitor the status of the anti-malware. So you can do that by integrating your anti-malware solution with Azure Security Center to monitor the status of your anti-malware protection. So what are the reports available in Security Center? You can get reports for endpoint protection not installed on your Azure VMs or the endpoint protection not installed on non-Azure computers. Some endpoint protection health issues reports like signature out of the date, no real-time protection, not reporting, unknown, etc. So please do have a look in Azure Security Center for these reports. The next topic we need to understand is Privileged Access Workstations. Privileged Access Workstation or PAWs provide a dedicated system for sensitive tasks that is protected from internet attacks and threat vectors. Separating these sensitive tasks and accounts from the daily use workstations and devices provide very strong protection from phishing attacks, application, and OS vulnerabilities. PAW is hardened and locked down workstations designed to provide high security assurance for sensitive account and task. So what are these attacks? The first one is internet attacks. Isolating the privileged access workstations from the open internet is a key element to ensuring the PAW is not compromised. The second is usability risk. If a PAW is too difficult to use for daily tasks, administrators will be motivated to create workarounds to make their job easier. Third type is environment risk. Minimizing the use of management tools and accounts that have access to the PAW to secure and monitor these specialized workstations. Then we have supply chain tampering. Tracking a few key actions can mitigate critical attack vectors that are readily available to attackers. This includes validating the integrity of all installation media and using a trusted and reputable supplier for hardware and software. Then we have physical attacks. Because PAWs can be physically mobile and used outside of physically secure facilities, they must be protected against attacks that leverage unauthorized physical access to the computer. Let's look at the architecture overview. This diagram is an example which showing a separate channel for administration, which is a highly sensitive task that is created by maintaining separate dedicated administrative accounts and workstation. This architectural approach builds on the protections found in the Windows 10 Credential Guard and Device Guard features and goes beyond those protection for sensitive account and tasks. This methodology is appropriate for accounts with access to high value assets. So, what are the high value assets? The first one is administrative privileges. PAWs provide increased security for high impact IT administrative roles and tasks. This architecture can be applied to administration of many types of systems, including Active Directory domains and Forest, Microsoft Azure Active Directory tenants, Office 365 tenants, supervisory control and data acquisition or SCADA systems, ATMs, and POS devices. The second asset is high sensitivity information workers. The approach used in a PAW can also provide protection for highly sensitive information worker tasks and personnel such as those involving pre-announcement merger and acquisition activity, pre-release financial reports, organizational social media presence, executive comms, unpatented trade secrets, sensitive research, etc. So what is a jump box? Administrative jump box architecture set up a small number of administrative console servers and restrict personnel to using them from administrative tasks. This is typically based on remote desktop services, a third-party presentation virtualization solution, or a virtual desktop infrastructure, which is a VDI technology. This approach is frequently proposed to mitigate risk to administration and does provide some security assurances. But the jump box approach by itself is vulnerable to certain attacks because it violates the clean source principle. This example figure shows how reversing the control relationship and accessing user apps from an admin workstation give the attacker no path to the target object. The user jump box is still exposed to risk, so appropriate protective controls, detective controls, and response process should still be applied for that internet facing computer. So, what are virtual machine templates? Before diving into configuring VM policies and templates, you need to understand the features and functionalities of Azure Resource Manager. Resource Manager is the deployment and management service for your Azure subscription. It provides a consistent management layer that allows you to create, update, and delete resources in your Azure subscription. You can use its access control, auditing, and tagging features to help secure to organize your resources after deployment. You can use the Resource Manager template to define your VMs. After they are defined, you can easily deploy and redeploy them. I recommend periodically redeploying your VMs to force the deployment of a freshly updated and security enhanced VM OS. So let's dive deep into template design. How you define templates and resource groups is entirely up to you and how you want to manage your solution. For example, you can deploy 3-tier application through a single template to a single resource group, but you don't have to define your entire infrastructure in a single template. Often it makes sense to divide your deployment requirement into a set of targeted purpose-specific templates. You can easily reuse these templates for different solutions. To deploy a particular solution, you create a master template that links all required templates. If you envision your tiers having separate lifecycle, you can deploy the 3 tiers to separate resource group. Please note that when you deploy a template, Resource Manager converts the template into a REST API operations. So let's understand how can you connect and sign into virtual machines you created on Azure. Once you're successfully connected, you can work with the VM as if you were locally logged into the host server. So let's learn how can you connect to a Windows virtual machine. The most common way to connect to a Windows-based VM running in Azure is by using Remote Desktop Protocol or RDP. Most versions of Windows natively contain support for Remote Desktop Protocol. If you're connecting to a Windows VM from a Mac, you will need to install an RDP client for Mac. So how can you connect to a Linux-based VM? To connect to a Linux-based VM, you need a Secure Shell Protocol SSH client. Another way to connect to Azure is by using Azure Bastion. Azure Bastion service is a fully platform managed PaaS service that you provision inside your virtual network. It provides secure and seamless RDP SSH connectivity to your virtual machine directly in your Azure portal over TLS. When you connect using Azure Bastion, your virtual machine does not need a public IP address. Bastion provides secure RDP and SSH connectivity to all the VMs in your virtual network in which it is provisioned. Using Azure Bastion protects your virtual machines from exposing RDP or SSH ports to the outside world. With Azure Bastion, you connect to the virtual machine directly from the Azure portal. Let's understand how can you update virtual machines. Azure Update Management is a service included as part of your Azure subscription. With Update Management, you can access your update status across your environment and manage your Windows Server and Linux Server updates from a single location for both your on-premises and Azure environments. Azure Management is available at no additional cost, and you can easily enable it for your Azure and on-premises VMs. Azure Automation uses runbooks to install these updates. You can't view these runbooks, but they don't require any configuration. When an update deployment is created, it creates a schedule that starts a master update runbook and the specified time for the included computers. The master runbook starts a child runbook on each agent to install the required updates. And you can use Update Management solution to manage update and patches for your Windows and Linux virtual machines as well. From your Azure Automation account, you can onboard virtual machines, assess the status of available updates, schedule installation of required updates, and review deployment results to verify that updates are applied successfully to all virtual machines for which update management is enabled. The log analytics agent for Windows and Linux need to be installed on the VMs that are running on your corporate network or other cloud environment in order to enable them with the update management. After you enable update management for your machines, you can view machine information by selecting the computers. From there, you can view information about the machine name, compliance status, environment, operating system type, critical and security updates installed or not, other updates installed or not, things like that. Let's understand disk encryption. Azure Disk Encryption helps protect and safeguard your data to meet your organizational security and compliance commitments. It uses the BitLocker feature of Windows to provide volume encryption for the operating system and data disk of Azure virtual machines, and is integrated with Azure Key Vault to help you control and manage the disk encryption keys and secrets. If you use Azure Security Center, you are being alerted if you have Azure VMs that aren't encrypted. The alerts show as high severity, and the recommendation is to encrypt these VMs. So, what are the supported VMs and operating systems? Windows VMs are available in a range of sizes. Azure encryption is not available on basic A series VMs or virtual machines with less than 2 GB memory. Azure Disk Encryption is also available for VMs with premium storage. Azure Disk Encryption is not available on Generation 2 VMs and LSV2 series VMs. So, what are the supported operating systems? It supports Windows Client, which means Windows 8 and later, then Windows Server, which is Windows Server 2008 R2 and later. Now, let's understand the networking requirements. To enable Azure Disk Encryption, the VMs must meet the following network endpoint protection. To get a token to connect to your Key Vault, the Windows VMs must be able to connect to the Azure Active Directory endpoint. And to write the encryption keys to the Key Vault, the Windows VMs must be able to connect to the Key Vault endpoint. If your security policy limits access from Azure VMs to the internet, you can resolve the preceding URI and configure a specific rule to allow outbound connectivity to the IPs. So, what are the group policy requirements? Azure Disk Encryption uses the BitLocker external key protector for Windows VMs. For domain joined VMs, don't push any group policies that enforce TPM protectors. Azure Disk Encryption will fail if domain level group policy blocks the AES-CBC algorithm, which is used by BitLocker. And the last one is encryption key storage requirements. Azure Disk Encryption requires an Azure Key Vault to control and manage disk encryption keys and secrets. Your Key Vault and VMs must reside in the same Azure region and subscription. Let's understand Windows Defender. Windows 10, Windows Server 2019, and Windows Server 2016 include key security features. They are Windows Defender Credential Guard, Windows Defender Device Guard, and Windows Defender Application Control. Windows Defender Credential Guard uses virtualization-based security enhancement to isolate secrets so that only privileged system software can access them. Unauthorized access to these secrets might lead to credential theft attacks such as pass the hash or pass the ticket attacks. Windows Defender Credential Guard helps prevent these attacks by helping protect integrated Windows authentication, which is NTLM password hashes, Kerberos authentication ticket granting tickets, and credentials that applications store on domain credentials. And Windows Defender Application Control helps mitigate these types of threats by restricting the application that users can run and the code that runs in the system core or kernel. Policies in Windows Defender Application Control also block unassigned scripts and MSIs, and Windows PowerShell runs in constrained language mode. Let's look at some of the Security Center recommendations. Azure Security Center helps you prevent, detect, and respond to threats with increased visibility and control over the security of your Azure resources. Security Center helps you safeguard VM data in Azure by providing visibility into the security settings of your VMs. So, what are the capabilities available? You can get OS security settings with the recommended configuration rules. You get security system updates and critical updates that are missing, endpoint protection recommendations, disk encryption validation, vulnerability assessment and remediation, and threat detection. You need to enable data collection so that Azure Security Center can gather the information it needs to provide recommendation and alerts based on security policy you configure. This is an example of the data collection has been turned on. Security Center threat detection works by automatically collecting security information from your Azure resources, the network, and connected partner solutions. It analyzes this information, often correlating information from multiple sources to identify threats. Security Center prioritizes alerting along with recommendations on how to remediate these threats. And Security Center employs advanced security analytics that go far beyond signature based approaches. And Security Center takes advantage of breakthroughs in big data and machine learning technologies to evaluate events across the entire cloud fabric, detecting threats that would be impossible to identify via manual approaches and predicting the evolution of attacks. Some of these analytics include integrated threat intelligence. This seeks known malicious hackers by taking advantage of global threat intelligence from Microsoft product and services, the Microsoft Digital Crimes Unit, and the Microsoft Security Response Center and external feeds. The next one is behavior analytics. This applies known patterns to discover malicious behavior. And the third one is anomaly detection. This uses statistical profiling to build a historical baseline. It sends alerts on deviations from established baselines that confirm to potential attack vectors. Using these analytics, Security Center can help disrupt the kill chain by adding detection in different phases of the kill chain, as shown in this example. Microsoft Cybersecurity Group, in conjunction with Center of Internet Security, which is known as CIS, has developed best practices to help establish security baseline for Azure protection. The CIS Microsoft Azure Foundation Security Benchmark Guide provides perspective guidance for establishing a secure baseline configuration for Azure. A variety of security standards can help cloud service customers to achieve workload security when using these cloud services. These recommendations should not be considered an exhaustive list of all possible security configuration and architectures, but just as a starting point. Alright, so that concludes the episode on host security. In the next video, we're going to enter a brand new episode, which is episode 11, and the topic is container security. Let's have a high level look at the things what we are going to learn in this video. We will start with what are containers and how it works, and then we will learn about what is ACI, which is Azure Container Instances. Then we will learn about AKS, which is Azure Kubernetes Services, what are AKS terminologies, and what are the architecture it based on. Then we will learn about networking, storage, and how AKS and Active Directory work together. So without wasting any more time, let's get into it. So what are containers? A container is an isolated, lightweight silo for running an application on the host operating system. Containers build on top of the host operating system's kernel and contain only apps and some lightweight operating system APIs and services that run in user mode. While a container shares a host operating system's kernel, but the container doesn't get access to it. Instead, the container gets an isolated and in some cases, virtualized view of the system. For example, a container can access a virtualized version of the file system and registry, but any changes affect only the container and are discarded when it stops. To save data, the container can mount persistent storage such as Azure Disk or file share, including Azure Files. You need Docker in order to work with Windows Container. Docker consists of Docker Engine and Docker Client. So what are the features of containers? The first feature is isolation. Typically provides lightweight isolation from the host and other containers, but doesn't provide as strong a security boundary as a VM. Second feature is operating system. Containers runs the user mode portion of an operating system and can be tailored to contain just the needed service for your app using fewer system resources. The next one is deployment. You can deploy individual containers by using Docker via command line, and you can deploy multiple containers by using an orchestrator such as Azure Kubernetes Service. And the next one is persistent storage. You can use Azure Disk for local storage for a single node, or Azure Files, which is an SMB shares, for storage shared by multiple nodes or servers. And containers are fault tolerant. If a cluster node fails, any containers running on it are rapidly recreated by the orchestrator on another cluster node. Let's talk about ACI security. Containers are built from images that are stored in one or more repositories. These repositories can belong to a public registry like Docker Hub or to a private registry. You can monitor and scan container images continuously. You can take advantage of solution to scan container images in a private registry and identify potential vulnerabilities. It's important to understand the depth of threat detection that the different solutions provide. And you can use the vulnerability management as part of your container development lifecycle. By using effective vulnerability management throughout the container development lifecycle, you improve the odds that you identify and resolve security concerns before they become a more serious problem. New vulnerabilities are discovered all the time, so scanning for and identifying vulnerabilities is a continuous process. Let's learn about what is Azure Container Instances or ACI. Azure Container Instances is a PaaS service for scenario that can operate in isolated containers, including simple applications, task automation, and build jobs. For scenarios where you need full container orchestration, including service discovery across multiple containers, automatic scaling, and coordinated application upgrades, Microsoft recommends Azure Kubernetes Service. So, what are the features of Azure Container Instances? Let's go through one by one. First one is fast startup times. Containers offer significant startup benefits over virtual machines, and Azure Container Instances can start containers in Azure in seconds without the need to provision and manage VMs. The second feature is Container Access. Azure Container Instances enable exposing your container groups directly to the internet with an IP address and fully qualified domain name. And Azure Container Instances also support executing a command in a running container by providing an interactive shell to help with application development and troubleshooting. Another feature is container deployment. You can deploy containers from Docker Hub or Azure Container Registry. Next feature is hypervisor level security. Historically, containers have offered application dependency isolation and resource governance, but have not been considered sufficiently hardened for hostile multi-tenant usage. Azure Container Instances guarantees your application is as isolated in a container as it would be in a VM. Another feature is custom sizes. Azure Container Instances provide optimum utilization by allowing exact specification of CPU cores and memory. Another feature is you get persistent storage. So to retrieve and persist state with Azure Container Instances, Microsoft offer direct mounting of Azure file shares backed by Azure Storage. Another great feature is you get flexible billing, which supports per GB or per CPU or per second billing. So you can basically choose which one you want. Another great feature is it supports Linux and Windows containers. You get co-scheduled groups and virtual network deployment as well. We mentioned about Azure Container Registry or ACR a couple of times. So what is a registry? A container registry is a service that stores and distributes container images. Docker Hub is a public container registry that supports the open source community and serves as a general catalog of images. Azure Container Registry provides users with direct control of their images with integrated authentication, geo-replication supporting global distribution, and reliability for network closed deployments. In addition to Docker container images, Azure Container Registry supports related content artifacts including Open Container Initiative or OCI image formats. Let's understand security and access. You log into registry using Azure CLI or standard Docker login command. Security features of the premium SKU include content trust for image tag signing and firewalls and virtual network to restrict access to the registry. Azure Security Center optionally integrates with Azure Container Registry to scan images whenever an image is pushed to a registry. What about the repository? Container registries manage repositories, collection of container images or other artifacts with the same name but different tags. And finally, how can you monitor container activity and user access? You can use log analytics. Log analytics can help you view and manage your Docker and Windows container host in a single location. Let's understand the Azure Container Registry authentication. There are several ways to authenticate with Azure Container Registry, each of which is applicable to one or more registry usage scenarios. These recommended ways include authenticating to a registry directly via individual login or your application, and container orchestrators can perform unattended or headless authentication by using Azure Active Directory service principle. This following table lists the available authentication methods and recommended scenarios. Now, what is Azure Kubernetes Service? Azure Kubernetes Service is a managed Kubernetes offering that further simplifies container-based application deployment and management. Kubernetes is a rapidly evolving platform that manages container-based application and their associated networking and storage components. The focus is on application workloads, not the underlying infrastructure components. Kubernetes provides a declarative approach to deployments, backed by a robust set of APIs for management operations. You can build and run modern portable microservices based applications that benefit from Kubernetes orchestrating and managing the availability of those application components. Kubernetes support both stateless and stateful application as teams progress through the adoption of microservices based applications. Azure Kubernetes Service or AKS provide a managed Kubernetes service that reduces the complexity of deployment and core management tasks, including coordinating upgrades. The AKS control plane is managed by the Azure platform, and you only pay for the AKS node that runs your applications. AKS is built on top of the open source Azure Kubernetes Service Engine, which is AKS Engine. So, what are the features of Azure Kubernetes Services? AKS is fully managed, and you can use public IP and FQDN, and it can be accessed with RBAC or Azure AD. You can dynamically scale containers, and you can run automation for rolling updates and rollbacks of containers as well. Let's look at AKS architecture. When you create an AKS cluster, a cluster master is automatically created and configured. This cluster master is provided as a managed Azure resource abstracted from the user. There is no cost for the cluster master, only the nodes that are part of the AKS cluster. The cluster master includes some of the following core Kubernetes components. The first one is Kube API server. The API server is how the underlying Kubernetes APIs are exposed. These components provide the integration of management tools such as Kubelet or Kubernetes dashboard. Then we have etcd. To maintain state of your Kubernetes cluster and configuration, the highly available etcd is a key value store within Kubernetes. The next one is Kube scheduler. When you create or scale application, the scheduler determines what nodes can run the workload and starts them. The last one is Kube Controller Manager. The Controller Manager oversees a number of smaller controllers that perform actions such as replicating pods and handling nodes operations. Let's learn some of the AKS terminologies as well. So, what are pools? Pools are a group of nodes with identical configuration, and nodes are individual virtual machines running containerized applications. And pods are single instance of an application, and a pod can contain multiple containers as well. Deployment means one or more identical pods managed by Kubernetes. And finally, manifest means YAML file describing a deployment. In AKS, cluster master nodes provide the core Kubernetes service and orchestration for application workloads. In AKS, the Kubernetes master components are part of the managed service provided by Microsoft. Each AKS cluster has its own single tenanted, dedicated Kubernetes master to provide the API server, scheduler, etc. This master is managed and maintained by Microsoft. Let's look at how AKS networking looks like. To simplify the network configuration for application workloads, Kubernetes uses services to logically group a set of pods together and provide network connectivity. It includes cluster IP, which creates an internal IP address for use within the AKS cluster, and good for internal only applications that support other workloads within the cluster. Then we have node port, which creates a port mapping on the underlying node that allows the application to be accessed directly with the node IP address and port. Then we have the load balancer, which creates an Azure load balancer resource, configures an external IP address, and connects the requested pods to the load balancer backend pool. The last one is external name. This creates a specific DNS entry for easier application access. Now let's learn about AKS storage. Applications that run in Azure Kubernetes Service may need to store and retrieve data. For some application workloads, this data storage can use local, fast storage on the node that is no longer needed. For some application workload, this storage can be local. Fast storage on the node that is no longer needed when the pods are deleted. Other application workloads may require storage that persists on more regular data volume within the Azure platform. You can manually create these data volumes to be assigned to pods directly or have Kubernetes automatically create them. There are two types of data volumes you can create. One is Azure Disk and Azure Files. Azure Disk can be used to create Kubernetes data disk resource, and Azure Files can be used to mount an SMB 3.0 share backed by Azure Storage account to pods. Now let's understand how AKS can be integrated with Azure Active Directory. With Azure Active Directory integrated AKS clusters, you can grant users or groups access to Kubernetes resources within a namespace or across the cluster. This approach provides a single source for user account management and password credentials. The user can only access the resources as defined by the cluster administrator. So that concludes episode 11, which was all about container security. In the next video, we're going to do a knowledge check on all the episodes what we have completed under module 2. Let's look at the first question. Which of the following two features of Azure networking provide the ability to redirect all internet traffic back to your company's on-premises servers for packet inspection? You need to select two. So the correct answer is user-defined routes and force tunneling. You can use force tunneling to redirect internet-bound traffic back to your company's on-premises infrastructure. Force tunneling is commonly used in scenarios where organizations want to implement packet inspection or corporate audits. Force tunneling in Azure is configured via Virtual Network User-Defined Routes or UDR. Let's look at question number 2. You are configuring Azure Firewall. You need to allow Windows Update network traffic through the firewall. Which of the following should you use? You just need to choose one answer. So it is definitely not network rules or NAT rules or destination inbound rules. The correct answer is application rules. Application rule defines fully qualified domain names or FQDNs that can be accessed from a subnet. That would be appropriate to allow Windows Update network traffic. Let's look at question number 3. You would like to limit outbound internet traffic from a subnet. Which product should you install and configure? So the correct answer is Azure Firewall. Azure Firewall will let you limit the outbound IP address and port that can be accessed. You can define network rule that defines source address, protocol, destination port, and destination address. Let's look at question number 4. Your organization has a web application and is concerned about attacks that flood the network layer with a substantial amount of seemingly legitimate traffic. What should you do? The correct answer is create a DDoS policy. Creating a DDoS policy to provide defense against the exhaustion resources. This exhaustion could make an application unavailable to legitimate users, for example. Let's have a look at question number 5. You are deploying the Azure Application Gateway and want to ensure incoming requests are checked for common security threats like cross-site scripting and crawlers. To address your concerns, what should you do? The correct answer is install the Web Application Firewall. The Web Application Firewall, or WAF, is an optional component that handles incoming requests before they reach a listener. The Web Application Firewall checks each request for many common threats based on the Open Web Application Security Project, or OWASP. Which services below are features of Azure Application Gateway? We need to select 3 answers. This is definitely not authentication. The correct answer is Layer 7 load balancing, offloading of CPU-intensive SSL terminations, round-robin distribution for incoming traffic. Azure Application Gateway is a dedicated virtual offering, offers Layer 7 load balancing capabilities for your application. It lets customers to optimize web farm productivity by offloading CPU-intensive SSL termination to the application gateway, round-robin distribution of incoming traffic, and cookie-based session affinity, URL path-based routing, and the ability to host multiple websites behind a single application gateway. Let's look at question number 7. You are configuring a network security group. All the following default rules except which one is right. So we have 3 right answers and 1 wrong answer. So the wrong answer here is, but which is the correct answer for the question, is allow internet inbound. NSGs have default inbound and outbound rules. There is a default allow internet outbound rule, but not an allow internet inbound rule. Let's look at question number 8. Your organization has web servers in different regions and you want to optimize the availability of the servers. Which of the following is best suited for this purpose? The correct answer is Azure Front Door. Azure Front Door lets you define, manage, and monitor the global routing for your web traffic by optimizing for best performance and instant global failover for high availability. Let's look at question number 9. Your organization has a security policy that prohibits exposing SSH ports to the outside world. You need to connect to an Azure Linux virtual machine to install software. What should you do? The correct answer is configure the Bastion service. The Azure Bastion service provides secure and seamless RDP and SSH connectivity to your virtual machines directly in the Azure portal over SSL. When you connect via Azure Bastion, your virtual machines do not need a public IP address. Let's look at question number 10. What type of disk encryption is used for Linux disk? The correct answer is DMCrypt. Azure Disk Encryption is a capability that lets you encrypt your Windows and Linux IaaS VMs disk. Azure Disk Encryption leverages the industry standard BitLocker feature of Windows and DMCrypt feature of Linux to provide OS and data disk encryption to help protect and safeguard your data. Let's look at question number 11. You need to ensure your virtual machines are kept up to date with security patches. Update management, including all of the following except which one? So the correct answer is update management only pertains to cloud deployed virtual machines. Update management pertains to virtual machines in on-premises environment and in other cloud environments as well. Question number 12. Which of the following is not a high severity security center recommendation for virtual machines and servers? You need to select one answer. The right answer is install endpoint protection solution on virtual machines. This is a medium severity recommendation. Privileged access workstations provide all the following except one. Protection against attackers who have gained administrative access. Privileged access workstation cannot protect against an attacker that has already gained access. Question number 14. To interact with Azure APIs, an Azure Kubernetes Service AKS cluster require which of the following? You need to select two answers. The correct answers are Azure AD Service Principal and Managed Identity. To interact with Azure APIs, an Azure AKS cluster requires either an Azure AD Service Principal or a Managed Identity. A service principal or managed identity is needed to dynamically create and manage other Azure resources such as Azure Load Balancer or Azure Container Registry. Let's look at question number 15. You are using Azure Kubernetes Service or AKS and needed to control the flow of traffic between pods and block traffic directly to the backend application. What should you do? Select one. The correct answer is create a AKS network policy. The principle of least privilege should be applied to how traffic can flow between pods in an Azure Kubernetes service cluster. The network policy feature in Kubernetes lets you define rules for ingress and egress traffic between pods in a cluster. Let's look at the last question. You are defining RBAC rules for the Azure Kubernetes security team. You need to grant permission across the entire cluster. Which two items would you define? You need to select two answers. So the right answer is cluster roles and cluster role bindings. Roles are used to grant permissions within a namespace. If you need to grant permissions across the entire cluster or to cluster resources outside a given namespace, you can instead use cluster role. Once the roles are defined to grant permission to resources, you assign these Kubernetes RBAC permission and with a role binding. Role bindings are used to assign roles for a given namespace. If you need to bind roles across the entire cluster or to cluster resources outside a given namespace, you can instead use cluster role bindings. Alright, so that concludes Module 2. In the next video, we are starting Module 3, and the first lesson we are going to learn in Module 3 is all about Azure Key Vault. Let's have a high-level look at the things what we are going to learn in this video. We will start with understanding what are Azure Key Vault features, then how can you access Azure Key Vault, some of the examples on how you can use the Azure Key Vault, and we will understand about certificates and how can you manage the keys within the Key Vault. And we will learn about some of the concepts called Key Vault secrets and rotation as well. So without wasting any more time, let's get into it. So what is Azure Key Vault? Azure Key Vault helps safeguard cryptographic keys and secrets that cloud applications and services use. Key Vault streamlines a key management process and enables you to maintain control of keys that access and encrypt your data. Developers can create keys for development and testing in minutes, and then migrate them to production keys. Security administrators can grant and revoke permission to keys as needed. You can use Key Vault to create multiple secure containers called vaults. Vaults help reduce the chances of accidental loss of security information by centralizing application secret storage. Key vaults also control and log the access to anything stored in them. So let's have a look at some of the issues Key Vault helping us resolve. The first one is secrets management. You can use Azure Key Vault to securely store and tightly control access to tokens, passwords, certificates, API keys, and other secrets. The second issue Key Vault trying to resolve is key management. You can use Key Vault as a key management solution, making it easier to create and control the encryption keys used to encrypt your data. The third one is certificate management. Azure Key Vault is also a service that lets you easily provision, manage, and deploy public and private SSL TLS certificates for use with Azure and your internal connected resources. And the fourth issue Azure Key Vault trying to resolve is ability to store secrets backed by hardware key modules or HSMs. The secrets and keys can be protected either by softwares or HSMs or hardware security modules. Let's look at Key Vault access. Access to Key Vault is controlled through two interfaces, the management plane and the data plane. The management plane is where you manage Key Vault itself. Operations in this plane include creating and deleting key vaults, retrieving key vault properties, and updating access policies. The data plane is where you work with the data stored in a key vault. You can add, delete, and modify key secrets and certificates from here. To access Key Vault in either plane, all users or applications must have proper authentication and authorization. Authentication establishes the identity of the caller, and authorization determines which operations the caller can execute. Both planes use Azure AD for authentication. For authorization, the management plane uses RBAC and the data plane uses Key Vault access policy. So let me show you how you can access Key Vault. So I'm on my Azure portal, go to all services and type Azure Key Vault and create a new Key Vault. So when you create a Key Vault in Azure subscription, it automatically associated with Azure AD tenant of the subscription. All callers in both planes must register in this tenant and authenticate to access the Key Vault. So let me create my first Key Vault. I'm going to create a new resource group, provide a Key Vault name, pick a region, pricing tier. We have two options, standard and premium. The main difference between standard and premium is that premium support HSM protected keys. So I'm going to pick standard. By default, soft delete is enabled. You can define the number of days you want to retain the data. You can either click review create or you can go to access policies as well. You can create additional access policies by clicking on add and create from a template as well. Additionally, you can configure the network settings to allow access to public endpoints, or do you want to restrict to a private endpoint, etc. And click on review create. After the validation is passed, you can click on create. So you get a notification which states that what is happening under Azure Resource Manager. Key Vault deployment fairly takes about 1 minute, so you would be able to provision your Key Vault super fast. So we talked about data plane and management plane. And this model of single mechanism for authentication for both planes have several benefits. So what are these benefits? Organizations can centrally control access to all Key Vault in their organization. If a user leaves, they instantly lose access to all Key Vaults in the organization. And organizations can customize authentication by using the option in Azure AD, such as to enable multi-factor authentication for added security. Let's look at a Key Vault example. In this example, we are developing an application that uses certificates for SSL, Azure Storage to store data, and RSA 20048-bit key for sign operations. Our application runs in Azure Virtual Machine or Virtual Machine scale set, and we can use a Key Vault to store the application secrets. We can store the bootstrap certificates that used by the application to authenticate with Azure AD. We need to access the following stored keys and secrets. So SSL certificate is used for SSL, storage key is used to access the storage account, RSA is used to sign operations, and bootstrap certificate is used to authenticate with Azure AD. So we need to define following roles to specify who manage, deploy, and audit the application. So the security team is the IT staff from your office of the CSO. Developers and operators are the staff who develop the application and deploy it in the Azure. And auditors is for contributors who aren't members of the development and general IT staff. So what do? They basically review the use of maintenance of certificates, keys, secrets to ensure compliance with security standards. So security team create the key vault, turn on key vault login, add keys and secrets, create backup of keys for disaster recovery, and set key vault access policies to grant permission to users and application for specific operations. And they get access to role the key and secrets periodically. And the developers and operators get references from the security team for the bootstrap and SSL certificates, storage key, which is secret URI, and RSA key as well. And they develop and deploy the application to access keys and secrets programmatically. When a key vault certificate is created, it can be retrieved from the addressable secret with the private key in either PFX or PEM format. However, the policy used to create the certificates must indicate that the key is exportable. If the policy indicates non-exportable, then the private key isn't a part of the value when retrieved as a secret. Let's understand keys. Cryptographic keys in Key Vault are represented as JSON Web Key or JWK objects. There are two types of keys depending on how they are created. The first one is soft keys, a key processed in software by Key Vault but is encrypted at rest using system key that is in hardware security modules. Clients may import an existing RSA or EC key or request the Key Vault generate one. The second type is hard keys. Hard keys are the keys which is processed in HSM or hardware security module. These keys are protected in one of the Key Vault HSM security vaults. Clients may import an RSA or EC key in soft form or by exporting form to compatible HSM device. Clients may also request Key Vault to generate a key as well. So what are the key operations you can perform? Key Vault support many operations on key objects. The first one is create. Create allows a client to create a key in Key Vault. The value of the key is generated by Key Vault and stored and isn't released to the client. This allows a client to import an existing key to Key Vault. A symmetric key may be imported to Key Vault using a number or different packaging method within a JWK construct. Then we have update. This allows a client with sufficient permissions to modify the metadata associated with a key previously stored within the Key Vault. And then we have delete, which allows a client with sufficient permissions to delete key from the Key Vault. Then we have cryptographic operations as well. Once a key has been created in the Key Vault, you can either do sign in and verify, or key encryption and wrapping, or you can do encrypt and decrypt as well. Let's talk about customer managed keys. Once you have created your Key Vault and have populated it with keys and secrets, the next step is to set up the rotation strategy. The next step is to set up the rotation strategy for the values you store as Key Vault secrets. Secrets can be rotated in several ways. First one is as part of a manual process. Then you can rotate by programmatically by using REST API calls or through an Azure automation script as well. You can enable this feature on any Azure Resource Manager storage account using the Azure portal, Azure PowerShell, Azure CLI, or the Microsoft Azure Storage Resource Provider API as well. Now let's understand Key Vault secrets. Key Vault provides secure storage for secrets such as passwords and database connection strings. So how can you access Key Vault secret? I'm on my Azure portal. Go to your Key Vault and right under settings, you can select secrets. From a developer perspective, Key Vault APIs accept and return secrets values as strings. Internally, Key Vault stores and manages secrets as sequence of octets with a maximum size of 25k bytes. The Key Vault service doesn't provide semantics for secrets. It merely accepts the data, encrypts it, stores it, and return a secret identifier. For highly sensitive data, clients should consider additional layer of protection for data. So you have an option to either create a manual entry or using a certificate as well. If you use manual, you have an ability to use a name value pair. Your name should be a unique one in the vault. Value can be any UTF-8 string, maximum of 25 KB in size. Then you can provide the activation date and activation expiry date as well. Once you have keys and secrets stored in the key vault, it is very important to think about a rotation strategy. There are several ways to rotate the values. You can either use a manual process, or you can use a programmatically used as API calls, or you can use Azure automation script as well. This example diagram shows how event grid and logic apps can be used to automate the process. So that concludes this lesson. In the next video, we're going to talk about application security. Let's have a high-level look at the things what we're going to learn in this video. We will start with learning about Microsoft Identity Platform. What are the different types of Azure AD application scenarios? How can you register an app? And we will talk about different types of Microsoft Graph permissions. We will discuss about Microsoft Managed Identities and web app certificates as well. So without wasting any more time, let's get into it. Microsoft Identity Platform is an evolution of Azure Active Directory developer platform. It allows developers to build applications that sign in users, get tokens to call APIs, such as Microsoft Graph, or APIs that developers have built. It consists of an authentication service, open source libraries, application registration and configuration, a developer portal and application API, full developer documentation, quick start samples, code samples, tutorials, how-to guides, and other developer content. Microsoft Identity Platform supports industry standard protocols such as OAuth 2.0 and OpenID and OpenID Connect. This is an example diagram. Showing the Microsoft Identity experience at a high level. This includes the app registration experience, software development kits or SDKs, endpoints, and supported identities. The Microsoft Identity Platform has two endpoints, version 1 and version 2, and two sets of client libraries to handle these endpoints. When developing a new application, consider the advantages and the current state of the endpoints and the authentication libraries. Microsoft Identity Platform version 2 endpoint is now OIDC certified. It works with Microsoft Authentication Libraries, which is MSAL, or any other standards compliant library as well. It implements human readable scopes in accordance with industry standards. Let's understand Azure AD application scenarios. Any application that outsources authentication to Azure AD needs to be registered in a directory. This step involves telling Azure AD about your application. In Azure AD, an application object describes an application as an abstract entity. Developers work with applications. At deployment time, Azure AD uses a specific application object as a blueprint to create a service principal, which represents a concrete instance of an application within a directory or tenant. It's the service principal that defines what the app can do in a specific target directory, who can use it, what resources it has access to, and so on. Azure AD creates a service principal from an application object through consent. Let's look at the workflow here. The first step is from a user B tries to sign in with the app. Second step is where Azure AD gets and verifies user credentials. And the third step is where Azure AD prompts the user to consent for the app to gain access to the tenant B. Fourth step is where Azure AD uses application object in A as a blueprint for creating service principal in B. And the fifth step is where the user receives the requested token. Let's understand app registration. Before your application can get a token from Microsoft Identity Platform, it must be registered in the Azure portal. Registration integrates your app with your Microsoft Identity Platform and establishes the information that it uses to get tokens, including application ID, redirect URI or URL, and application secret. So what is an application ID? Application ID is a unique identifier assigned by the Microsoft Identity Platform. Then what is the redirect URI or URL? One or more endpoints at which your application will receive responses from the Microsoft Identity Platform. For native and mobile apps, this is a URI assigned by the Microsoft Identity Platform. The last is application secret, a password or a public-private key pair that your app uses to authenticate with the Microsoft Identity Platform. That is called application secret. Let's understand Microsoft Graph permissions. Microsoft Graph exposes granular permissions that control the access that apps have to resources like user, groups, and mail. As a developer, you decide which permission to request for Microsoft Graph. When a user signs into your app, they or in some cases an administrator are given a chance to consent to these permissions. If the user consents, your app is given access to the resources and APIs that it has requested. Microsoft Graph has two types of permissions: delegated permissions and application permissions. Let's understand what is delegated permissions. Delegated permissions are used by apps that has a signed-in user present. For these apps, either the user or an administrator consent to the permissions that the app requests, and the app can act as the signed-in user when making calls to Microsoft Graph. So what are application permissions? Application permissions are used by apps that run without a signed-in user present. For example, apps that run as background service or daemons. Application permissions can only be consented by an administrator. Let's understand Microsoft Graph API. You can use the Microsoft Graph Security API to connect Microsoft security products, services, and partners to streamline security operations and improve threat protection, detection, and response capabilities. The Microsoft Security API is an intermediary service that provides a single programmatic interface to connect multiple Microsoft Graph security providers. The Microsoft Security Graph API federates requests to all providers in the Microsoft Graph security ecosystem. This is based on the security provider consent provided by the application, as shown in this example figure. The consent workflow only applies to non-Microsoft providers. So the Microsoft Graph API makes it easy to connect with security solutions from Microsoft and partners. It allows you to more readily realize and enrich the value of these solutions. And you can connect easily with the Microsoft Graph Security API by using one of the following approaches depending on the requirements. Let's understand what is managed identities. A common challenge when building cloud applications is how to manage the credentials in your code for authenticating to cloud services. Keeping the credentials secure is an important task. Ideally, the credentials never appear on developer workstation and aren't checked into source control. Azure Key Vault provides a way to securely store credentials, secrets, and other keys, but your code has to authenticate to Key Vault to retrieve them. Managed Identities for Azure Resources is a new name for the service formerly known as Managed Service Identity or MSI for Azure Resources. The feature provides Azure services with an automatically managed identity in Azure AD. You can use the identity to authenticate to any service that supports Azure AD authentication, including Key Vault, without any credentials in your code. The managed identities for Azure Resources is totally free with Azure AD for Azure subscriptions. There is no additional cost to use it. So this is an example diagram which shows how managed service identities work with Azure virtual machines. Now let's understand web app certificates. You can restrict to your Azure App Service app by enabling different types of authentication for it. One way to do it is to request a client certificate when the client request is over TLS or SSL and validate the certificate. This mechanism is called TLS mutual authentication or client certificate authentication. To access your site over HTTP and not HTTPS, you will not receive any client certificate. So if your application requires client certificates, You should not allow requests to your application over HTTP. Alright, so that concludes application security in Azure. In the next video, we're going to learn about storage security in Azure. Let's have a high level look at the things we are going to learn in this video. We will start with understanding what is data sovereignty, what is Azure Storage Access, and how can you implement shared access signatures. Then we will learn about Azure AD storage authentication and storage service encryption as well. After that, we will learn about blob data retention policies, how can you access Azure files and what is Azure files authentication looks like, and what is secure transfer required. Without wasting any more time, let's get into it. So what is data sovereignty? Data sovereignty is the concept that information which has been converted and stored in binary digital form is subject to the laws of the country or region in which it is located. Many of the current concerns that surround data sovereignty relate to enforcing privacy regulations and preventing data that is stored in a foreign country or region from being subpoenaed by the host country or region's government. In Azure, customer data might be replicated within a selected geographic area for enhanced data durability in case of a major data center disaster, and in some cases will not be replicated outside of it. The first thing we need to understand is what are paired regions. Azure operates in multiple geographies around the world. An Azure geography is a defined area of the world that contains at least one Azure region. An Azure region is an area within a geography containing one or more data centers. Each Azure region is paired with another region within the same geography, forming a regional pair. The exception is Brazil South, which is paired with a region outside of its geography. Across the region pairs, Azure serializes platform updates so that only one paired region is updated at a time. In the event of an outage affecting multiple regions, one region in each pair will be prioritized for recovery. So, what are the benefits of Azure paired regions? Let's understand the first benefit, which is about physical isolation. When possible, Azure services prefer at least 300 miles of separation between data centers in a region pair. Physical data center separations reduces the likelihood of both regions being affected simultaneously as a result of natural disasters, civil unrest, power outages, or physical network outages. Isolation is subject to the constraint within the geography, such as geography size, power, and network infrastructure availability and regulations. The second benefit is platform provided replication. Some services such as geo-redundant storage provide automatic replication to the paired region. And the third benefit is region recovery order. In the event of a broad outage, recovery of one region is prioritized out of every pair. The next benefit is sequential updates. Planned Azure system updates are rolled out to paired regions sequentially, not at the same time. This helps minimize downtime, the effect of bugs, and logical failures in the rare event of bad update. The last benefit is data residency. To meet data residency requirement for tax and law enforcement, a region resides within the same geography as its pair. Alright, so let's understand Azure Storage Access. Every request made against a secured resource in the blob, file, queue, or table service must be authorized. Authorization ensures that resources in your storage account are accessible only when you want them to be, and only to those users or application to whom you grant access. So what are the options? The first one is Azure AD. Azure Storage provides integration with Azure Active Directory for identity-based authorization of requests to blob and queue services. The next one is Azure Active Directory Domain Services or ADDS authorization. This is active for Azure Files. Azure Files support identity-based authorization over Server Message Block or SMB through ADDS. You can use RBAC for fine-grained control over a client access to Azure file resources in a storage account. The next one is shared key. Shared key authorization relies on your account access keys and other parameters to produce an encrypted signature string that is passed on via the request in the authorization header. The fourth option is shared access signature. A shared access signature or SAS is a URI that grants restricted access rights to an Azure storage resource. And the last option is anonymous access to containers and blobs. You can enable anonymous public read access to a container and its blobs in Azure Blob Storage. By doing so, you can grant read-only access to these resources without sharing your account key and without requiring a shared access signature. Now let's understand what is shared access signature or SAS. As a best practice, you shouldn't share storage account keys with external third-party applications. If these apps need access to your data, you will need to secure their connections without using storage account keys. For untrusted clients, use a shared access signature. A shared access signature is a string that contains a security token that can be attached to a URI. Use a shared access signature to delegate access to storage objects and specify constraints such as permissions and the time range of access. So let me show you where you can find the storage access signature. I'm on my Azure portal. I'm going to go to a random storage account. I'm going to click on this storage account. Right under settings, you can click on shared access signature. So this is where you can find this shared access signature settings and options. There are three types of shared access signature you need to be aware of: service level, account level, and user delegation SAS. You can use service level shared access signature to allow access to specific resource in a storage account. You can use account level shared access signature to allow access to anything that a service level shared access signature can allow, plus additional resources and abilities. And the third type is a user delegation SAS. A user delegation SAS is secured with Azure AD credentials. This type of SAS is supported for the blob service only and can be used to grant access to containers and blobs. Now let's understand Azure AD storage authentication. In addition to shared key and shared access signature, Azure Blob and Queue Storage support using Azure Active Directory to authorize storage requests. With Azure AD, you can use role-based access control or RBAC to grant permission to security principal, which may be a user, group, or application service principal. The security principal is authenticated by Azure AD to return an OAuth 2.0 token. Authorization with Azure AD is available for all general purpose and blob storage account in all public regions and national clouds. Built-in storage roles are provided including owner, contributor, and reader. The role can be scoped from management group to individual blob or queue. The best practices dictate granting only the narrowest possible scope, and RBAC role assignments may take up to 5 minutes to propagate. So please be aware of that. Now let's understand storage service encryption. Azure Storage provide a comprehensive set of security capabilities that together enable developers to build secure applications. Azure Storage encryption is enabled for all new and existing storage accounts and cannot be disabled. Because your data is secured by default, you don't need to modify your code or application to take advantage of Azure Storage encryption. Encryption does not affect Azure Storage performance. There is no additional cost for Azure Storage encryption as well. You can rely on Microsoft Managed Key for the encryption for your Azure Storage account, or you can manage encryption with your own keys as well. If you choose to manage encryption with your own key, you have two options. You can specify a customer managed key to use for encrypting and decrypting all data in the storage account, or you can specify a customer provided key on blob storage operations as well. Next topic we need to understand is blob data retention policies. Immutable storage for Azure Blob Storage enables users to store business critical data objects in a warm, which is write once, read many state. This state makes the data non-erasable and and non-modifiable for a user-specified interval. For the duration of the retention interval, blobs can be created and read, but cannot be modified or deleted. Immutable storage is available for general purpose V2 and blob storage account in all Azure regions. So let me show you how you can find that. I'm on my Azure portal. I'm going to go back to my storage account. Click on storage account and go to your blob container. So I'm going to create a container. So right on the left hand side under setting for the container, click on access policies. And within the settings, you can find immutable blob storage. And when you click on add policy, you can either find legal hold or time-based retention. So what is time-based retention? In time-based retention policy support, users can set policies to store data for a specific interval. When a time-based retention policy is set, blobs can be created and read, but not modified or deleted. So what is legal hold? Under legal hold policy support, if the retention interval is not known, users can set legal holds to store immutable data until the legal hold is cleared. When a legal hold policy is set, blobs can be created and read, but not modified or deleted. Other immutable storage features include support for all blob tiers, container level configuration, and audit logging support. Now let's understand Azure Files authentication. Azure Files support identity-based authentication over server message block or SMB through on-premises Active Directory domain services and Azure Active Directory domain services as well. Azure Files enforces authorization on user access to both the share and the directory file levels as well. Share level permissions assignment can be performed on Azure Active Directory users or group managed through the role-based access control model. So what are the advantages of identity-based authentication? Identity-based authentication for Azure Files offers several benefits over the shared key authentication. It extends the traditional identity-based file share access experience to the cloud with on-premises ADDS and Azure ADDS. So if you plan to lift and shift your application to the cloud, replacing traditional file servers with Azure file shares, then you may want your application to authenticate with either on-premises ADDS or Azure ADDS credential to access file data. Azure Files supports using both on-premises ADDS or Azure ADDS credential to access Azure File Share over SMB from either on-premises ADDS or Azure ADDS domain join VMs. So let's look at an example where I can show you identity-based authentication data workflow. So the first step is, before you can enable authentication on Azure File Shares, you must first set up your domain environment. Second step is, when an identity associated with application running on a VM attempts to access data in Azure File Share, the request is sent to Azure ADDS to authenticate the identity. And the third step is, if the authentication is successful, Azure ADDS returns a Kerberos token. And the fourth and the final step is, the application sends a request that includes the Kerberos token, and Azure File Shares use the token to authorize the request. And the last topic is secure transfer required. You can configure your storage account to accept requests from secure connection only by setting the secure transfer required property for the storage account. When you require secure transfer, any requests originating from an insecure connections are rejected. Microsoft recommends that you always require secure transfer for all of your storage accounts. When secure transfer is required, a call to the Azure Storage REST API operation must be made over HTTPS. Any request made over HTTP is rejected. By default, the secure transfer required property is enabled when you create a storage account. Azure Storage doesn't support HTTPS for custom domain names. This option is not applied when you are using a custom domain name. So that concludes the lesson on storage security in Azure. In the next video, we're going to learn about database security. Let's have a high-level look at the things we are going to learn in this video. So we talked about data sovereignty in the previous episode. So that is similar and applicable to this episode as well. If you have not watched and don't know about data sovereignty, I would encourage you to watch the previous episode. We will start with understanding what is SQL database authentication and how can you implement SQL database firewalls, database auditing, etc. Then we will learn about data discovery and classification and how can you view and access the vulnerability assessment. How can you turn on advanced threat protection? Other topics we discuss is dynamic data masking, transparent data encryption, and always encrypted. So without wasting any more time, let's get into it. So what is SQL database authentication? First, let's discuss about authentication and authorization. Authentication is the process of proving the user is who they claim to be. A user connects to a database using a user account. When a user attempts to connect to a database, they provide a user account and authentication information. The user is authenticated using one of the following two authentication methods. Either they will use SQL Server authentication or Azure Active Directory authentication. So what is SQL authentication? With SQL authentication method, the user submits a user account name and associated password to establish a connection. This password is stored in the master database for the user account linked to a login or stored in a database containing the user accounts not linked to a login. The second type of authentication method is using Azure Active Directory authentication. With this authentication method, the user submits a user account name and requests that the service use the credential information stored in Azure Active Directory. You can create a user account in the master database and grant permission in all databases on the server, or you can create them in the database itself. So let's understand logins and user. A login is an individual user in the master database to which a user account in one or more databases can be linked. With a login, the credential information for the user account is stored with the login. And what is a user account? A user account is an individual account in any database that may be but does not have to be linked to a login. With a user account that is not linked to a login, the credential information is stored with the user account. And finally, what is authorization? Authorization to access data and perform various actions are managed using database roles and explicit permissions. Authorization refers to the permissions assigned to a user and determines what the user is allowed to do. And authorization is controlled by your user account database role membership and object level permissions. Alright, so now let's discuss about Azure database firewalls. Initially, all access to your Azure SQL database is blocked by the SQL database firewall. So let me show you how you can see that firewall settings. I'm on my Azure portal. I'm going to create a new service. This time I'm going to search for Azure SQL. Select Azure SQL and click on create. So for this example, I'm going to create a simple single database. Click on create. Select the subscription. Select a resource group. Provide a database name. I don't have a server yet, so I'm going to create a new server. Give a username and password and choose a preferred location. I'm going to keep it East US itself. Click OK. That will create a server in the backend. And do you want to be Elastic Pool? Because this is a demo, I don't want to be an Elastic Pool. I'm going to keep it as it is. I'm going to change the database size to something which is really low. So I'm not going to exhaust all the cost on my subscription. Go to networking. I'm going to leave it as default and I'm going to click on review create. So this would probably take a couple of minutes. So I'm going to pause the video now. All right, the Azure SQL database is created. I'm going to click on go to resource. So I'm not going to spend much time over here explaining all the components. So if you're interested, you can watch the AZ-104 tutorial where I have explained in detail how you can set up and configure the database and what are the settings and options you need to be aware of. So one particular topic which we are going to discuss today is set the firewall by default. So this is turned on by default. So when you go inside this, to access a database server, you must specify one or more server level IP firewall rules that enable access to your Azure SQL database. Use the IP firewall rule to specify which IP address range from the internet are allowed and whether Azure application can attempt to connect to your Azure SQL database. To selectively grant access to just one of the databases in your Azure SQL database, you must create a database level rule for the required database. And you can specify an IP address range for the database IP firewall rule that is beyond the IP address range specified in the server level IP firewall rule, and ensure that IP address of the client falls in the range specified in the database level rule. When a computer attempts to connect to your database server from the internet, the firewall first checks the originating IP address. The firewall first checks the originating IP address of the request against the database level IP firewall rules for the database that the connection is requesting. So how is it connecting from Azure? To allow application from Azure to connect to your Azure SQL database, the Azure connections must be enabled. When an application from Azure attempts to connect to your database server, the firewall verifies that the Azure connections are allowed or not. Please note that whenever possible, as a best practice, use database level IP firewall rules to enhance security and to make your database more portable. Use server level IP firewall rules for administrators, and when you have several databases with the same access requirement, you don't want to spend time configuring each database individually. Let's talk about database auditing. Auditing for Azure SQL Database and Azure Synapse Analytics tracks database events and writes them to an audit log in your Azure Storage account, Log Analytics workspace, or even hubs. You can use audit for retain an audit trail of selected events, and you can define categories of database actions to be audited as well. Then you can use auditing to report on database activity, and you can turn on analyze to report as well. An auditing policy can be defined for a specific database or as a default server policy. A server policy applies to all existing and newly created database on the server. If server auditing is enabled, it always applies to the database. The database will be audited regardless of the database auditing settings. Enabling auditing on the database or data warehouse, in addition to enabling it to on a server, does not override or change any of the settings on the server auditing. Both audits will exist side by side. In other words, the database is audited twice in parallel, once by the server policy and once by the database policy. This example is a configuration of auditing using the Azure portal. What is data discovery and classification? Data discovery and classification is built into Azure SQL Database. It provides advanced capabilities for discovering, classifying, labeling, and reporting the sensitive data in your database. Your most sensitive data might include business, financial, healthcare, or personal information. Discovering and classifying this data can play a pivotal role in your organization's information protection approach. Data discovery and classification is part of the Advanced Data Security offering, which is a unified package for advanced SQL security capabilities. You can access and manage data discovery and classification via the central SQL Advanced Data Security section of the Azure portal. Data encryption at rest is a mandatory step towards data privacy, compliance, and data sovereignty. And protecting data in transit should be an essential part of your data protection strategy. Because data is moving back and forth from many locations, Microsoft generally recommend that you always use SSL or TLS protocols to exchange data across different locations. In some circumstances, you might want to isolate the entire communication channel between your on-premises and cloud infrastructure using a VPN. Let's understand SQL Vulnerability Assessment. SQL Vulnerability Assessment is an easy-to-configure service that can discover, track, and help you remediate potential database vulnerabilities. You can use it to proactively improve your database security. Vulnerability Assessment is part of the Advanced Data Security offering, which is a unified package for advanced SQL security capabilities. Vulnerability Assessment can be accessed and managed via the central SQL Advanced Data Security portal. SQL Vulnerability Assessment is a service that provides visibility into your security state. Vulnerability assessment include actionable steps to resolve security issues and enhance your database security. It can help you meet compliance requirements that require database scan report. It can help you meet your data privacy standards as well. And it will help you monitor a dynamic database environment where changes are difficult to track. Vulnerability assessment is a scanning service built into Azure SQL database. The service employs a knowledge base of rules that flag security vulnerabilities. It highlights deviation from best practices such as misconfiguration, excessive permission, and unprotected sensitive data. The rules are based on Microsoft best practices and focus on security issues that presents the biggest risk to your database and its valuable data. They cover database level issues and server level security issues like server firewall settings and server level permissions. These rules also represent many of the requirements from various regulatory bodies to meet their compliance standards. Results of the scan include actionable steps to resolve each issue and provide customized remediation script where applicable. You can customize an assessment report for your environment by setting an acceptable baseline for permission configuration, feature configurations, and database settings. When your scan is finished, your scan report is automatically displayed in the Azure portal. The report presents an overview of the security states. It lists how many issues are found and their respective severities. Results include warning on deviations from the best practice and a snapshot of your security related settings such as database principal and roles and their associated permissions. The scan report also provides a map of sensitive data discovered in your database. It includes recommendations to classify that data by using data discovery and classification. Let's talk about advanced threat protection. Advanced threat protection can identify potential SQL injection, access from unusual location or data center, or access from unfamiliar principal or potentially harmful application, and brute force SQL credentials. Advanced threat protection for Azure SQL database detects anomalies activities indicating unusual and potentially harmful attempts to access or exploit databases, and it can trigger the following alerts. So what are the alerts? The first one is vulnerability to SQL injection. This alert is triggered when application generates a faulty SQL statement in the database. The second type is potential SQL injection. This alert triggered when an active exploit happens against an identified application vulnerability to SQL injection. The third type is access from unusual location. This alert is triggered when there is a change in the access pattern to SQL server where someone has logged on to the SQL server from an unusual geographic location. And the fourth type is access from unusual location or unusual Azure data center. This alert is triggered when there is a change in the access pattern to SQL server where someone has logged into an SQL server from an unusual geographic location. The next type is access from a potentially harmful application. This alert is triggered when a potentially harmful application is used to access the database. In some cases, the alert detects penetration testing in action. In other cases, the alert detects an attack using common attack tools. The last alert which I would like to highlight is brute force SQL credentials. This alert is triggered when there is an abnormal high number of failed logins with different credentials. In some cases, the alert detects penetration testing in action. In other cases, the alert detects brute force attacks. Let's talk about dynamic data masking. SQL database dynamic data masking or DDM limits sensitive data exposure by masking it to non-privileged users. Dynamic data masking helps prevent unauthorized access to sensitive data by enabling customers to designate how much of their sensitive data to reveal with minimal impact on the application layer. It is a policy-based security feature that hides the sensitive data in the result set of the query over designated database fields while the data in the database is not changed. You set up dynamic data masking policy in the Azure portal by selecting the dynamic data masking operation in the SQL database configuration blade or settings blade. This feature cannot be set by using portal in the Azure Synapse. You have three different types of dynamic data masking policy. They are SQL users excluding from masking, masking rules, and masking functions. The dynamic data mask recommendations engine flags certain fields from your database as potentially sensitive fields, which may be good candidates for masking. In the DDM blade in the Azure portal, you can review the recommended columns for your database. All you need to do is click Add Mask for one or more columns and then save to apply mask for these fields. Transparent Data Encryption (TDE) helps protect Azure SQL Database, Azure SQL Managed Instance, and Synapse SQL in Azure Synapse Analytics against the threat of malicious offline activity by encrypting data at rest. It performs real-time encryption and decryption of the databases, associated backups, and transcription log files at rest without requiring changes to your application. By default, TDE is enabled for all newly deployed Azure SQL databases and needs to be manually enabled for older database of Azure SQL Database, Azure SQL Managed Instance, and Azure Synapse. Customer Managed TDE is also referred to as Bring Your Own Key or BYOK support for TDE. With TDE with Azure Key Vault integration, users can control key management tasks including key rotations, key vault permissions, key backups, and enable auditing or reporting on all TDE protectors using Azure Key Vault functionality. Key Vault provides central key management and leverages tightly monitored HSMs and enables separation of duties between management of keys and data to help meet compliance and security policies. Last but not the least, let's understand what is always encrypted. Always encrypted is a feature designed to protect sensitive data such as credit card numbers or national identification numbers stored in Azure SQL Database or SQL Server databases. Always encrypted allows clients to encrypt sensitive data inside client applications and never reveal the encryption key to the database engine. As a result, Always Encrypted provides a separation between those who own the data and those who manage the data by ensuring on-premises database administrators, cloud database operators, or other high-privileged but unauthorized users cannot access the encrypted data. Always Encrypted enables customers to confidently store sensitive data outside of their direct control. This allows organizations to encrypt data at rest and in use for storage in Azure to enable delegation of on-premises database administration to third parties or to reduce security clearance requirements of their own DBA staff. Always Encrypted makes encryption transparent to applications. So what are the example usage scenarios? The first one I can think about is client on-premises with data in Azure, where a customer has an on-premises client application at their business location. The second scenario is client and data in Azure, where a customer has a client application hosted in Microsoft Azure. So what are the features of Always Encrypted? The first feature is deterministic encryption. Deterministic encryption always generates the same encrypted value for any given plain text value. The second one is randomized encryption. This uses a method that encrypts data in a less predictable manner. Randomized encryption is more secure but prevents searching, grouping, indexing, and joining on encrypted columns. Alright, so that concludes Module 3, and we just finished database security in Azure. In the next video, we're going to do a quick knowledge check on all the things what we have learned in Module 3. So let's look at the first question. Which one of the following should not be stored in Azure Key Vault? What are the differences between these items? Select one. It's definitely not key management, secret management, and certificate management. The correct answer is identity management. Azure Key Vault can be used for keys, secrets, and certificates. Keys are cryptographic objects. The Key Vault supports multiple key types and algorithms and enables the use of hardware security modules, or it is known as HSM, for high-value keys. Secrets provide secure storage for passwords and database connection strings. Certificates are built on top of keys and secrets and add an automated renewal feature. Let's look at question number 2. A select group of users must be able to create and delete keys in Key Vault. How should you grant these permission? The correct answer is role-based access control. To create and delete key vaults, the management pane uses RBAC, which is Role-based access control. For example, you could use a role called key vault contributor. Let's look at the third question. Which of these statements best describes Azure Key Vault's authentication and authorization process? You need to select one. The correct answer is applications and users authenticate to a vault with their Azure Active Directory identities and are authorized to perform actions on all secrets in the vault. Authentication to Key Vault uses Azure Active Directory identities. Access policies are used to provide authorization for actions that apply to every secret in the vault. Let's look at question number 4. How does Azure Key Vault help protect your secrets after they have been loaded by your app? Select one. The correct answer is it doesn't protect your secrets. Secrets are unprotected once they are loaded by your application. Once secrets have been loaded by an app, they are unprotected. Make sure to not log them, store them, or return them in client responses. Let's look at question number 5. Your manager wants to know more about software protected keys and hardware protected keys. You discuss which three of the following statements. Select 3. So the correct answer is software protected cryptographic operations are performed in software. Hardware protected cryptographic operations are performed within the HSM, and only the hardware protected keys offer FIPS 140-2 level 2 assurance. The primary difference besides price with the software protected key is when cryptographic operations are performed. They are done in the software using Azure Compute Services, while the HSM protected keys, the cryptographic operations are performed within the HSM. Let's look at question number 6. What method does Microsoft Azure App Service use to obtain credentials for user attempting to access an app? Select one. The correct answer is redirection to a provider endpoint. Microsoft Azure App Service apps redirect requests to an endpoint that signs in users for that provider. The app service can automatically direct all unauthenticated users to the endpoint that signs in users. Question number 7. What type of managed service identities can you create? Select 2. The correct answers are system assigned and user assigned. There are two types of managed identities. A system assigned managed identity is enabled directly on an Azure server instance. When the identity is enabled, Azure creates an identity for the instance in the Azure AD tenant that's trusted by the subscription of the instance. Creating an app with a user assigned identity requires that you create the identity and then add its resource identifier to your app configuration. Let's look at question number 8. Your app service application stores page graphics in an Azure storage account. The app needs to authenticate programmatically to the storage account. What should you do? Select one answer. The correct answer is create a managed identity. A managed identity is an Azure AD security principle that represents the resource app, which is managed identities can be user or system managed. Let's look at question number 9. How does using managed identities for Azure resources change the way an app authenticates to Azure Key Vault? Select one. The correct answer is the app gets token from a token service instead of Azure Active Directory. When you enable managed identity on your web app, Azure activates a separate token granting REST service specifically for use by your app. Your app will request tokens from this service instead of Azure Active Directory. Let's look at question number 10. You need to provide a contingent staff employee temporary read-only access to the contents of an Azure storage account container named media. It is important that you grant access while adhering to the security principle of least privilege. What should you do? And you just need to select one answer. The correct answer is generate a shared access signature token for the container. The SaaS or shared access signature can provide a read-only access. Let's look at question number 11. Your company has both a development and production environment. The development environment needs time-limited access to storage. The production environment needs unrestricted access to storage resources. You need to configure storage access to meet the requirements. What should you do? Each answer presents part of the solution. Select two. The first answer is use shared access signature for the development app. The second answer is use access keys for the production apps. Shared access signature provide a way to provide more granular storage access than access keys. For example, you can limit access to read only and you can limit the services and types of resources. Shared access signatures can be configured for the specific amount of time, which meets this scenario's requirements. Access keys provide unrestricted access to the storage resources, which is the requirement for the production app in this scenario. Let's look at question number 12. Your company is being audited. It is not known how long the audit will take, but during that time, files must not change or removed. It is okay to read or create new files. What should you do? Select two. Each correct answer is required for the solution. The first correct answer is add legal hold retention policy to the blob container. The second option is identify a tag for the items that are being protected. If the retention interval is not known, users can set legal holds to store immutable data until the legal hold is cleared. When a legal hold policy is set, blobs can be created and read, but not modified or deleted. Each legal hold is associated with a user-defined alphanumeric tag such as case ID, event name, etc. that is used as an identifier string. Let's look at question number 13. You are configuring an Azure file share for the business group. Which of the following is not true? Select one. The correct answer is Azure files can use RBAC for share level or directory file permissions. Only share level permission can use RBAC. Let's look at question number 14. You are configuring secure transfer required. Your compliance office want to know more about this feature. You provide all the following information except which one? The correct answer is request to storage can be HTTPS or HTTP. When secure transfer required is enabled, all requests must be HTTPS. Let's look at question number 15. Your SQL database administrator has recently read about SQL injection attacks. They ask you what can be done to minimize the risk of this type of attack. You suggest implementing which of the following features? The correct answer is Advanced Threat Protection. Advanced Threat Protection is an advanced data security feature for databases. The feature provides alerts when a potential attack like SQL injection occurs. Question number 16. Your organization provides a help desk for its customers. Service representatives need to identify callers using the last four numbers of their credit card. You need to ensure the complete credit card number is not fully exposed to the service representatives. Which of the following feature do you implement? The correct answer is dynamic data masking. Dynamic data masking limits sensitive data exposure by masking it to non-privileged users. This feature enables customers to designate how much of the sensitive data is to reveal. Let's look at question number 17. Your organization auditors need to be assured that sensitive database data always remains encrypted at rest, in transit, and in use. You assure the auditors this is being done because you have configured which feature. The feature you're looking for is called Always Encrypted. Always Encrypted helps protect sensitive data at rest on the server during movement between client and server and while the data is in use. Always Encrypted ensures that sensitive data never appears as plain text inside the database system. After you configure data encryption, only client applications or app servers that have access to the keys can access plain text data. Let's look at question number 18. You have an app service web application uses a SQL database. Users need to authenticate to the database with their Azure AD credentials. You perform all the following tasks except which one? The correct answer is create user in the master DB. You could not create users in the master DB. Instead, contained user should be created on each database. Let's look at the last question. What type of firewall rule can you configure for the Azure SQL database? Select two. The first answer is server level firewall rule, and the second answer is database level firewall rules. Server level IP firewall rule enables client to access your entire Azure SQL database, that is, all the database within the same SQL database server. These rules are stored in the master database. Database level IP firewall rules enable clients to access certain secure databases within the same SQL database server. You can create these rules for each database, including the master database, and they are stored in the individual databases. So we just finished module 3 knowledge check. In the next video, we are starting a brand new module, which is module 4. And the first lesson is all about Azure Monitor. Let's have a high level look at the things what we are going to learn in this video. We will understand what is Azure Monitor and what are the components involved in the Azure Monitor. Things like metrics and logs. And what is Azure Log Analytics? And how can you use Azure Log Analytics for connected sources? And we will talk about Azure Monitor alerting as well. Then we will finish off with diagnostics and logging. So without wasting any more time, let's get into it. So what is Azure Monitor? Azure Monitor maximizes the availability and performance of your applications and services by delivering a comprehensive solution for collecting, analyzing, and acting on telemetry from your cloud and on-premises environments. It helps you understand how your applications are performing and proactively identifies issues affecting them and the resources they depend on. This example high-level diagram shows the two fundamental data types that Azure Monitor uses: metrics and logs. On the left-hand side, this shows the sources of monitoring data that populate these data stores. And on the right-hand side, it shows the different functions that Azure Monitor performs with this collected data, such as analysis, alerting, streaming to external systems, etc. All data that Azure Monitor collects fits into one of two fundamental types: metrics or logs. So what are metrics? Metrics are a numerical value that describes some aspect of system at a particular time. Metrics are collected at regular intervals and are useful for alerting because they can be sampled frequently, and an alert can be fired quickly with relatively simple logic. So what are the list of different ways that can use a metric data in Azure Monitor? You can use analyze, visualize, alert, automate, export, retrieve, and archive. So now let's understand what are Azure Monitor logs. Logs in Azure Monitor contain different kinds of data organized into records with different sets of properties for each type. Logs can contain numeric value like Azure Monitor metric, but typically contain text data with detailed descriptions. They further differ from metric data in that they vary in their structure and are often not collected at regular intervals. Telemetry such as events and traces are stored Azure Monitor logs in addition to performance data so that it can all be combined for analysis. A common type of log entry is an event, which is collected sporadically. Events are created by an application or service and typically include enough information to provide complete context of their own. For example, an event can indicate that a particular resource was created or modified, a new host started in response to increased traffic, or an error was detected in an application. So what are the list of different ways that you can use logs in Azure Monitor? You can use it for analyzing, visualizing, alert, retrieve, and export. Let's go a little deep into log analytics. Log analytics is part of Microsoft Azure's overall monitoring solution. Log analytics helps you monitor cloud and on-premises environment to maintain availability and performance. Log analytics is the primary tool in the Azure portal for writing log queries and interactively analyzing their results. Even if a log query is used elsewhere in Azure Monitor, you will typically write and test the query first using log analytics. You can start log analytics from several places in Azure portal. The scope of the data available to log analytics is determined by how you start it. Let's look at some of the areas in Azure Monitor you will use these queries. First, let's look at alert rules. Alert rules proactively identify issues from data in your workspace. Each alert rule is based on a log search that is automatically run at regular intervals. The results are inspected to determine if an alert should be created. Second area in Azure Monitor where you will use the queries are dashboards. You can pin the results of any query in an Azure dashboard, which allow you to visualize log and metric data together and optionally share with other Azure users. The third area where you can see the results is views. You can create visualizations of data to be included in user dashboards with View Designer. Log queries provide the data used by tiles and visualization parts in each view. Fourth area is export. When you import log data from Azure Monitor into Excel or Power BI, you create a log query to define the data to export. Another area is PowerShell. You can run a PowerShell script from a command line or an Azure automation runbook that uses get-az operation all inside search results to retrieve log data from Azure Monitor. The last area in the Azure Monitor is Azure Monitor Logs API. The Azure Monitor Logs API allows any REST API clients to retrieve log data from the workspace. The API requests include a query that is run against Azure Monitor to determine the data to retrieve. Let's understand connected sources. The Log Analytics agent was developed for comprehensive management across virtual machine in any cloud, on-premises machines, and those monitored by System Center Operations Manager. The Windows and Linux agents send collected data from different sources to your Log Analytics workspace in the Azure Monitor, as well as any unique logs or metrics as defined in the monitoring solution. The Log Analytics agent also supports insights and other services in Azure Monitor, such as Azure Monitor for VMs, Azure Security Center, and Azure Automation. The Azure Diagnostic extension in Azure Monitor can also be used to collect monitoring data from the guest operating system of Azure virtual machines. You can choose to use either or both depending on your requirements. The key differences to consider are Azure Diagnostic Azure Diagnostic extension can be used only with Azure virtual machines. The Log Analytics agent can be used with virtual machines in Azure, other clouds, and on-premises. And the Log Analytics agent is required for solutions, Azure Monitor for VMs, and other services such as Azure Security Center. Azure Diagnostic extension send data to Azure Storage, Azure Monitor Metrics, and even hubs. And the Log Analytics agent collects data to Azure Monitor logs. Let's talk about Azure Monitor Alerts. In addition to allowing you to interactively analyze monitoring data, an effective monitoring solution must be able to proactively respond to critical conditions identified in the data that it collects. This could be sending a text or mail to an administrator responsible for investigating an issue, or you could launch an automated process that attempts to correct an error condition. Alerts in Azure Monitor proactively notify you of critical conditions and potentially attempt to take corrective action. Alert rules based on metrics provide near real-time alerting based on numeric values, while rules based on logs allow for complex logic across data for multiple sources. Alert rules in Azure Monitor use action groups, which contain unique set of recipients and actions can be shared across multiple rules. Based on your requirements, action groups can perform such actions as using webhooks to have alerts start external actions or to integrate with your ITSM tools. This is an example which shows the key attributes of an alert rule. We have target group defines the scope and signals available for alerting. Then we have signals, which is emitted by the target resource. We have criteria, which is a combination of signal and logic applied on a target resource. And we can have actions as well, a specified action taken when alert is fired. Azure Monitor Diagnostic Logs are logs produced by an Azure service that provide rich, frequently collected data about the operation of that service. Azure Monitor makes two types of diagnostic logs available: tenant logs and resource logs. So what is tenant logs? Tenant logs comes from tenant level services that exist outside of an Azure subscription, such as an Azure Active Directory. Then we have resource logs. Resource logs come from Azure services that deploy resources within the Azure subscription, such as network security groups or storage accounts. You can configure diagnostic setting in the Azure portal either from the Azure Monitor menu or from the menu for the resource. These logs differ from the activity log. The activity log provides insight into operations such as or deleting a logic app, etc. Activity log is a subscription level log, and these logs also differ from guest operating system level diagnostic logs as well. So that concludes Azure monitoring lesson. In the next video, we're going to talk about Azure Security Center. Let's have a high level look at the things what we're going to learn in this video. We will start with understanding what is cyber kill chain, and I will introduce you to Azure Security Center, and we will go through some of the features as well. Then we will look into Azure Security Center policies and recommendations, and what are secure score, and how are these brute force attacks enforced. And we will finish off the lesson with understanding what is just-in-time access for the virtual machine. So without wasting any more time, let's get into it. The Security Center's threat protection includes Fusion Kill Chain Analysis, which automatically correlates alerts in your environment based on cyber kill chain analysis to help you better understand the full story of an attack campaign, where it started and what kind of impact it had on your resources. So let me help you understand the typical steps that raise the stages of a cyber attack. The first step is reconnaissance, the observation stage where attackers assess your network and services to identify possible targets and techniques to gain entry. The second step is intrusion. This is where attackers use knowledge gained in the reconnaissance phase to get access to a part of your network. This often involves exploring a flaw or security hole. Third stage or third step is exploitation. This phase involves exploiting vulnerabilities and inserting malicious code onto the system to get more access. And the third step is privilege escalation. This is when attackers often try to gain administrative access to compromised systems so they can get access to more critical data and move on to other connected systems. Fifth stage is lateral movement. This is the act of moving laterally to connected servers and gain greater access to potential data. The sixth stage is obfuscation and anti-forensics. To successfully pull off a cyber attack, attackers need to cover their entry. They will often compromise data and clear audit logs to try to prevent detection by any security team. And the seventh stage is denial of service. This phase involves disruption of normal access for users and systems to keep the attack from being monitored, tracked, or blocked. And the last stage is exfiltration. This is the final extraction stage, getting valuable data out of the compromised system. So now let's understand what is Azure Security Center. So before that, let me take you to the Azure portal and show you how you can access your Azure Security Center. I'm on my Azure portal. On the global search box, search for Azure Security Center and select Azure Security Center. Azure Security Center, or ASC, is a unified infrastructure security management system that strengthens the security posture of your data centers and provides advanced threat protection across your hybrid workload in the cloud, whether they are in Azure or not, as well as on-premises. Keeping your resources safe is a joint effort between your cloud provider, Azure, and you and the customer. Azure Security Center provides you with the tools needed to harden your network, secure your services, and make sure you are on top of the security posture. Security Center addresses the three most urgent security challenges. The first one is rapidly changing workloads. Second, increasingly sophisticated attacks. And the third one is security skills are in short supply. So let me take you through these one by one. Let's understand rapidly changing workloads. It's both a strength and a challenge of the cloud. On the one hand, end users are empowered to do more. On the other, how do you make sure that the ever-changing services people are using and creating are up to your security standards and follow security best practices? The second challenge which Azure Security Center addresses is increasingly sophisticated attacks. So wherever you run your workloads, the attackers keep getting more sophisticated. You have to secure your public cloud workloads, which are in fact an internet facing workload that can leave you even more vulnerable if you don't follow security best practices. And the third challenge which Azure Security Center addresses is security skills are in short supply. The number of security alerts and alerting systems far outnumbers the number of administrators with the necessary background and experience to make sure that your environment is always protected. Staying up to date with the latest attack is a constant challenge, making it impossible to stay in place while the world of security is ever changing front. So, to help you protect yourself against these challenges, security centers provide you with tools like strengthening your security posture. This is where Security Center assesses your environment and enables you with understanding the status of your resource and whether they are secure or not. The next tool is protect against threats. Security Center assesses your workload and raises the threat prevention recommendation and security alerts. And the last stage is get secure faster. In Security Center, everything is done in cloud speed. Because it's natively integrated, deployment of Security Center is easy, providing with auto provisioning and protection with Azure services. Let's talk about Azure Security Center policies. By default, all prevention policies are turned on. Prevention policies and recommendations are tied to each other. In other words, if you enable prevention policy such as OS vulnerabilities, that enables recommendation for that policy. In most situations, you want to enable all policies even though some might be more important to you than others, depending on the Azure resources you have deployed. So let me show you how you can access these policies. I'm on my Azure portal. Go to your Security Center. Under Management, click on Security Policy and select your subscription. Under Security Center Default Policy, click on View Effective Policy. This is where you can see all the auto-enabled and turned on features and policies. So I'm going to collapse. These policies will give you recommendations and best practices and alerts on system updates, OS vulnerabilities, endpoint protection, disk encryption, network security groups, web application firewall, next generation firewall, vulnerability assessment, SQL auditing threat detection, and SQL encryption. The next topic is Security Center recommendations. You can reduce the chances of a significant security event by configuring a security policy and then implementing the recommendations provided by Azure Security. Security Center automatically runs continuous scans to analyze the security state of your Azure resources. When Security Center identifies potential security vulnerabilities, it creates recommendations that guide you through the process of configuring the needed security controls. And Security Center updates the recommendation within 24 hours, except operating system security configuration recommendations. Those are updated within 48 hours. And endpoint protection issues recommendations are updated within 8 hours. And these recommendations are grouped by severity. Each recommendation provides you with a short description of what being recommended, the remediation steps to carry out in order to implement the recommendations, which resources are in need of you performing the recommended actions on them, and the secure score impact, which is the amount that your secure score will go up if you implement this recommendation. So since we are on the secure score topic, let me introduce you to what is secure score. Azure Security Center has two main goals: to help you understand your current security situation and to help you effectively and efficiently improve your security. The central aspect of Security Center that enables you to achieve these goals is Secure Score. The Security Center continually assesses your resources, subscriptions, and organization for security issues. It then aggregates all the findings into a single score so that you can tell at a glance your current security situation. The higher the score, the lower the identified risk level. Use the score to track security efforts and projects in your organization. The Secure Score page gives you the score. The Secure Score is shown as a percentage value, but the underlying values are also clear. Then we have the security controls. Each control is a logical group of related security recommendation and reflects your vulnerable attack surfaces. So how is the secure score is calculated? The contribution of each security control towards the overall secure score is shown clearly on the recommendation page. To get all the possible points of the security control, all your resources must comply with all of the security recommendations within the security control. For example, Security Center has multiple recommendations regarding how to secure your management ports. In the past, you could remediate some of these related and interdependent recommendations while leaving others unsolved, and your secure score would improve. When looked at objectively, it's easy to argue that your security hadn't improved until you have resolved them. Now you must remediate them all to make a difference to your security score. Now let's understand brute force attacks. Brute force is targeted. The hacker goes after specific users and cycles through as many passwords as possible using either a full directory or one that's edited to common passwords. An even more targeted password guessing attack is when the hacker selects a person and conducts research to determine if they can guess the user's password, discovering family names through social media posts, for example, and then trying those variants against an account to gain access. Brute force attacks commonly target management ports as a means to gain access to a VM. If successful, an attacker can take control over the VM and establish a foothold into your environment. And attackers target RDP servers that use weak password and are without multi-factor authentication, VPN, and other security protections. One way to reduce the exposure to the brute force attack is to limit the amount of time that a port is open. Azure Security Center leverages the Microsoft Intelligent Security Graph to discover and act against these attacks. The graph combines the cyber intelligence Microsoft collects across all the services along with the industry data to block known attack patterns. So, what are the indications of an attack? If you find extreme counts of failed sign-ins from many unknown usernames, that's an indication of an attack. And what are the practices to blunt a brute force attack? You can disable the public IP address, use Bastion host, or use point-to-site VPN, site-to-site VPN, or Azure Express Route, or enable multi-factor authentication, use complex password, and limit the time that the ports are open. And the last topic is just-in-time VM access. Just-in-time or JIT virtual machine. Just-in-time virtual machine access can be used to lock down inbound traffic to your virtual machines, reducing exposure to attacks while providing easy access to connect to VMs when needed. When you enable just-in-time VM access for your VMs, you can create a policy that determines the ports to help protect how long ports should remain open and approved IP address that can access these ports. The policy helps you stay in control of what users can do when they request access. Requests are lodged in Azure Security Log so you can easily monitor and audit access. The policy will also help you quickly identify the existing VMs that have just-in-time VM access enabled and the VMs where just-in-time VM access is recommended. When just-in-time VM access is enabled for a VM, Azure Security Center creates deny all inbound traffic rule for the selected ports in the network security group associated and firewalls within it. So that concludes Azure Security Center episode. In the next video, we're going to talk about Azure Sentinel. Let's have a high-level look at the things what we're going to learn in this video. We will learn what is Azure Sentinel and what are the features involved there and what are the features which comes as part of it. What are data connections? We will understand workbooks, incidents, and playbooks, and we will learn about hunting as well. So without wasting any more time, let's get into it. Microsoft Azure Sentinel is a scalable, cloud-native security information event management, or known as SIEM, and security orchestration automated response solution, which is known as SOAR. Azure Sentinel delivers intelligent security analytics and threat intelligence across the enterprise and providing a single solution for alert detection, threat visibility, proactive hunting, and threat response. So let me show you where you can find Azure Sentinel in your Azure portal. I'm on my Azure portal. You can go to the global search box and type in Azure Sentinel and search for Azure Sentinel. If you don't have a workspace created already, create one. I'm going to go inside the workspace I created. Microsoft Azure Sentinel offers nearly limitless cloud scale and speed to address your security needs. Think of Azure Sentinel as the first SIM as a service that brings the power of the cloud and artificial intelligence to help security operations team effectively identify and stop cyber attacks before they cause harm. Azure Sentinel enriches your investigation and detection by providing both Microsoft Threat Intelligence Stream as well as external threat intelligence streams. And Azure Sentinel integrates with Microsoft 365 solution and correlates millions of signals from different products such as Azure Identity Protection, Microsoft Cloud App Security, and soon Azure ATP, Windows Advanced Threat Protection, and Office 365 ATP, Intune, and AIP as well. You can use Azure Sentinel to collect data at cloud scale across all users, devices, application, and infrastructures, both on-premises and in multiple cloud. Then you can use Azure Sentinel to detect previously undetected threats and minimize false positives using Microsoft Analytics and unparalleled threat intelligence. And the third stage is investigate threats with artificial intelligence and hunt for suspicious activities at scale, tapping into years of cybersecurity work at Microsoft. And the last stage is respond to incident rapidly with built-in orchestration and automation of common tasks. Building on a full range of existing Azure services, Azure Sentinel natively incorporates proven foundations like log analytics and logic apps. Azure Sentinel enriches your investigation and detection with AI and provides Microsoft Threat Intelligence Stream and enables you to bring your own threat intelligence. Let's understand data connections. To onboard Azure Sentinels, you first need to connect to your security sources. Azure Sentinel comes with a number of connectors of Microsoft solutions available out of the box and providing real-time integration, including Microsoft Threat Protection Solution and Microsoft 365 sources, including Office 365, Azure AD, Azure ATP, and Microsoft Cloud App Security, and more. In addition, there are built-in connectors to broader security ecosystem for non-Microsoft solutions as well. Some services are connected natively, such as AWS and Microsoft services. These services leverage the Azure Foundation for out-of-the-box integration. Some data sources are connected using APIs that are provided by the connected data source. And Azure Sentinel can be connected to all other data sources that can perform real-time log streaming using the syslog protocol via an agent. Let's understand what are workbooks. After you connect your data sources to Azure Sentinel, you can monitor the data using the Azure Sentinel integration with Azure Monitor Workbooks, which provide versatility in creating custom workbooks. While workbooks are displayed differently in Azure Sentinel, it may be useful for you to determine how to create interactive report with Azure Monitor Workbooks. Azure Sentinel allows you to create custom workbook across your data and also comes with built-in workbook templates to allow you to quickly gain insight across your data as soon as you connect to a data source. Workbooks combine text, analytics query, Azure metrics, and parameters into rich interactive reports. So workbooks are helpful for scenarios like explaining to your team how a newly released feature is performing by showing user counts for key interactions and other metrics. Now let's understand what are incidents. Alerts triggered in Microsoft security solutions that are connected to Azure Sentinel, such as Microsoft Cloud App Security and Azure Advanced Threat Protection, do not automatically create incident in Azure Sentinel. By default, when you connect a Microsoft solution to Azure Sentinel, any alert generated in that service will be stored as raw data in Azure Sentinel. You can use that data like any other raw data you connect into Sentinel. You can create more than one Microsoft Security Analytic rule per Microsoft Security Service type. This does not create duplicate incidents, since each rule is used as a filter. Even if an alert matches more than one Microsoft Security Analytic rule, it creates just one Azure Sentinel incident. When you connect a Microsoft security solution, you can select whether you want the alerts from the security solution to automatically generate incidents in Azure Sentinel automatically. Now let's understand why playbooks. You can automate your common task and simplify security orchestration with playbooks that integrate with Azure services as well as your existing tools. Built on the foundation of logic apps, Azure Sentinel automation and orchestration solution provides a highly extensible architecture that enables scalable automation as new technologies and threats emerge. To build playbooks with Azure Logic Apps, you can choose from a growing gallery of built in playbooks. These include 200 plus connectors for services such as Azure Functions. The connections allow you to apply any custom logic to your code, like for ServiceNow, Jira, Zendesk, HTTP request, Microsoft Teams, Slack, Windows Defender ATP, and Cloud App Security. Now let's understand investigation and hunting. Azure Sentinel deep investigation tools help you understand the scope and find the root cause of a potential security threat. You can choose an entity on interactive graph to ask interesting questions for a specific entity and drill down into that entity and its connection to get to a root cause of the threat. The investigation graph provides you with visual context from the raw data, full investigation scope discovery, and built-in investigation steps. So what is hunting? You can use Azure Sentinel's powerful hunting search and query tools based on MITRE framework, which enables you to proactively hunt for security threats across your organization data sources before an alert is triggered. After you discover which hunting query provides high-value insight into possible attacks, you can also create custom detection rules based on your query and surface those insights as alerts to your security incident responders. Azure Sentinel hunting comes with lots of advantages. So let me take you through those one by one. The first one is built-in queries. To get you started, a starting page provides preloaded query examples designed to get you started and get you familiar with the tables and the query language. Those built-in hunting queries are developed by Microsoft security researchers on a continuous basis. The next advantage is you can create powerful query language with IntelliSense. Built on top of query language that gives you the flexibility you need to take your hunting to the next level. The next advantage is you can create your own bookmarks. During hunting process, you may come across matches or findings dashboards or activities that look unusual or suspicious. In order to mark those items so you can come back to them in the future. So you can use the bookmark functionality. Bookmarks lets you save items for later to be used to create an incident for investigation. The next advantage is use notebooks to automate investigation. Notebooks are step-by-step playbooks that you can build to walk through the steps of an investigation and hunt. Notebooks encapsulate all the hunting steps in a reusable playbook that can be shared with others in your organization. Alright, so that's a high-level view on Azure Sentinel, and that concludes our AZ-500 Azure Security Engineer Certification module. In the next video, we will do a quick knowledge check on all the things what we have learned in module 4. Let's look at the first question. Data collected by Azure Monitor collects fits into which two fundamental types? What are differences in those types of data? Select two. The correct answers are logs and metrics. All data collected by Azure Monitor fits into one of two fundamental types, metrics and logs. Metrics are numerical values that describe some aspect of a system at a point in time. They are lightweight and capable of supporting near real-time scenarios. Logs contain different kinds of data organized into records with different sets of properties for each type. Telemetry such as events and traces are stored as logs in addition to performance data so that it can all be combined for analysis. Let's look at question number 2. You can query Log Analytics Workspace with which of the following? The correct answer is Custo query language. All data is retrieved from Log Analytics Workspace using a log query written using Custo query language or KQL. You can write your own queries or use solutions and insight that include log queries for an application or service. Let's look at the third question. You want to be notified when any virtual machine in the production resource group is deleted. What should you configure? Select one. The correct answer is Activity Log Alert. An activity log alert to receive notification when specific changes occurs to resources in your Azure subscription. Let's look at question number 4. The IT managers would like to use a visualization tool for the Azure Monitor results. You suggest all the following except what? Logic apps. Logic apps would be used for integration activities. Workbooks are interactive documents that provide deep insight into your data, investigation, and collaboration inside the team. Specific examples where workbooks are useful are troubleshooting guides and incident postmortem. Dashboards and Power BI allow you to quickly identify important issues as well. Let's look at question number 5. Which of the following is not included in Azure Security Center free tier? Select one. The correct answer is monitor non-Azure resources. Security Center free tier doesn't support monitor external cloud or non-Azure resources. Question number 6. Your organization compliance group requires client authentication, use Azure AD, and key vault diagnostic logs to be enabled. What is the easiest way to accomplish this? Select one. The correct answer is implement Security Center policies. Security Center can monitor policy compliance across all your subscriptions using a default set of security policies. A security policy defines the set of controls that are recommended for resources within the specified subscription or resource group. Let's look at question number 7. Your Azure Security Center dashboard presents a secure score. How would you describe that score? Select one. The correct answer is the secure score is a calculation based on the ratio of healthy resources versus total resources. Security Center reviews your security recommendations across all workloads, user algorithms to determine how critical each recommendation is, and calculates a secure score which is displayed on the overview page. Let's look at question number 8. Your organization is working with an outside agency that need to access a virtual machine. There is a real concern about brute force login attacks targeted at virtual machine management ports. Which of the following can be used to open the management ports for a defined time range? Select one. The correct answer is just-in-time virtual machine access. Azure Security Center supports just-in-time virtual machine access. When just-in-time access is enabled, Security Center uses network security group rules to restrict access to management port when they are not in use, so they cannot be targeted by attackers. Let's look at question number 9. You are using Azure Security Center to provide visibility into your virtual machine security settings. With Azure Security Center monitoring, you can be notified of all the following except what? Select one. The correct answer is a newer operating system version is available. Azure Security Center examines OS level settings using a monitor service that it installs into each Windows and Linux VM. Azure Security Center can provide a vulnerability assessment with remediation recommendations. Let's look at question number 10. Where can you create and manage custom security alert? The correct answer is Azure Sentinel. Microsoft recommends that you enable Azure Sentinel and recreate your custom alert rule there. Question number 11. You are explaining what an Azure Sentinel playbook is and how it can be used. You cover all the following except which one. The correct answer is a Sentinel playbook is created to handle several subscriptions at once. All of the other statements are true. Let's look at question number 12. You are using Sentinel to investigate an incident. When you view the incident detail information, you see all of the following except which one. The correct answer is incident owner. The incident detail information include the severity, summary of the number of entities involved, the raw event that triggered the incident, and the incident's unique ID. Let's look at question number 13. You are an investigator who wants to be proactive about looking for security threats. You have read about Sentinel's hunting capabilities and notebooks. What is an Azure Sentinel notebook? Select one. The correct answer is notebook is a step-by-step playbook where you can walk through to the steps of an investigation and hunt. Other hunting techniques are described in the other choices, which is built-in query, bookmarks, and event tables. Let's look at the last question. You are creating roles within your security operations team to grant appropriate access to Azure Sentinel. All of the following are built-in Azure Sentinel roles, except which one? The correct answer is Azure Sentinel Owner. The Azure Sentinel's built-in roles are Reader, Responder, and Contributor. So that concludes AZ-500 tutorial. I will see you on a next video. Till then, take care.